Good morning, everyone. Thank you all for coming out bright and early for the next day of our Born Symposium. Today we'll be talking about a section of, well, for this presentation, we'll be talking about a small section of my PhD project, which involves reconstructing Maine's fire history using graded knowledge systems. So I'm a PhD student in Dr. Jacqueline Gill's lab, and my project is focused around understanding the past to inform the present, particularly as it comes to our fire history and how it shapes our modern distribution of tree species. And the overarching point of question here is centered around the fact that Western science does not actually agree on Maine's fire history. While regional processes have been really well documented, we understand our large-scale shifts in forest composition and how they relate to climate. The human versus climate drivers have not been well explored, nor have the local processes that affect more patchy distribution of forest composition. So looking at some background, there's this wonderful figure from Abrams and Nowaki's work from 2008, exploring pre-settlement versus current fire regime groups within the eastern US. And we go from fire regime group 1, which is high frequency fires, all the way up to 5, which is really low frequency, small scale fires. And you can see that there has been a drastic change in the fire regimes of these regions. We're actually seeing a lot less fire on the landscape now than is speculated to have been present on the landscape prior to European settlement. So we're looking at that regionally. It looks like Maine in particular, if we go back a slide, is very blue and teal, so not a whole lot of fire in the region. However, if we start looking at historical records, Wabanaki place names, and modern fire-built communities, it looks like Indigenous people may have actually been intentionally using fire to shape their landscapes on a really local scale. We see records like this etching from Matthias Marion from 1620 that show Wabanaki burning of Mount Desert Island for an annual moose hunt. And this is supposed to be a moose. we can use our imaginations. But these records are really scattered across central and coastal Maine. We start to see these small hints at a more fire-prone landscape throughout the different ways of knowing. So for my study sites, I am collecting sediment cores from lakes and small hollows across coastal and central Maine around areas of cultural significance and past archaeological site distribution. The importance between collecting these cores between different depositional environments is pretty big, because pond cores are larger catchment basins, so they're going to provide a more regional signal, whereas small hollows are just dips in the forested landscape, so they're going to provide a much more local signal. So we can start to disentangle what's happening kind of regional, what's this regional picture, versus what was happening in these really localized spots, and see how they overlap. So we're looking at differences in depositional environments, our fire histories at local and regional scales. And we're starting to get some really interesting stories out of this. We still have a lot of interpretation work to do here, but if we look at a small hollow core taken from right next to the Hurondo archaeological site versus a pond core here on the bottom from right nearby, this is from Perch Pond in Old Town, we see our charcoal accumulation rates on the y-axis over time on the x-axis. And if we look at the small hollow, we see that, well, there's not a whole lot of charcoal coming into the system until European arrival here near 0 or 1950 in our radiocarbon world. But if we look at the pond core, we see 3 distinct fire regimes. We see one of high accumulation rates with really peaky values until about 7,500 years before present, which this could be for a number of reasons. It could be because we're getting a certain type of fire on the landscape, either natural or anthropogenic ignition sources, but also Pushaw Lake and Perch Pond separated into 2 distinct catchment basins around this time. So we're seeing a change in our depositional environment. We could be going from a regional signal to one that's slightly smaller. But the other interesting thing is that it is suspected that people arrived at Hurondo around 7,000 years before present. So it's interesting to see we're getting changes in depositional environment, but also potentially land use that could be affecting our charcoal accumulation rates here. From radiocarbon dates, we know that the site was definitely being used by 5,000 years before present, but the lithic assemblage indicates that people may have been there as early as 7,000. But we see this entirely different fire regime from 7,000 years to about 3,200 years before present, before charcoal seems to drop off almost entirely. This is actually contradictory to what we thought it would look like because of the mid-Holocene warm period that is suspected to have been warmer and drier around 5,000, 4,000 years before present. We don't see an increase in fire in this site, which is weird. We have people there, we have warmer climate, more ripe for fire, and yet we're not seeing that record here. So then if we start calculating our fire return intervals through time, we can see that it does vary. We have our fire frequency, which is based on fires per 500-year period intervals over time. And it fluctuates between half a fire between to up to 3 fires or major fires above the background charcoal influx level over this period of time. We see that shift again at 7,500 years, and just lots more fluctuation between around 5,000 years, again between 4,000 and 3,000 years. And then it cuts off because we didn't have enough to calculate the values up until present because that charcoal really dropped off. When we calculate the mean fire return interval for this entire 12,000 year period, we see that over time, no matter how we shift our smoothing window, the values stay steady at around a 500-year fire return interval or period of time between significant fires within the system. And that's despite the number of peaks identified with the varying smoothing window. And this is interesting because then if we shift our attention to the coast, we see something entirely different. We see 2 distinct fire regimes with our charcoal accumulation rates on the y-axis and time on the x again, but we see a really peaky, irregular fire regime up until about from 12,000 to approximately 5,000 years before present, which is when humans arrive in the system, as far as we're aware. Shifting to a less peaky, lower charcoal accumulation rate until European arrival. And these dates need to be further constrained. We need to submit more radiocarbon. We need to submit more macrofossils for radiocarbon dating to see really what was going on from 5,000 years before present to present. But we're getting 2 different records from the coast and inland. Makes sense, they're different systems, but they're very, very different. It looks like there could be the potential that fire was highly localized, small patchwork within Maine, that it varied pretty substantially between sites and different human land use patterns, or maybe it was all responding to climate. We don't know. We need to better constrain these records and incorporate all these different records into our interpretation of these charcoal records. So when we look at our fire return intervals through time at Witchbowl Pond out on Mount Desert Island, we see our fire frequency for 500 years over time again. We're seeing higher fire frequency at our coastal sites. This one varies roughly between 2 and 4 significant fires for that 500-year period. And when we calculate that mean fire return interval, this one is at around 250 years. There's a big caveat for these records. Anthropogenic fire, specifically intentional use of low intensity fires, is really, really difficult to distinguish from background charcoal levels. It is very difficult to tell what was people and intentional fire versus what was just washing into a catchment basin. So we have a lot of work we need to do to further constrain these proxies to see what was people and what was climate. And one of the ways we're getting at that is through looking at charcoal morphotypes, or the size and type of charcoal within these records. These are examples of deciduous leaves, pine twigs, and forbs that burned. You can see they have branched to spongy morphotypes. If we look at this sample here, this is what we call bordered pits, this big black chunk over here. This is actually conifer wood that burned. So you can see a difference in the structure of the charcoal under the microscope. And we can use this to infer large changes in patterns of material burned through time. So if we're seeing lots more spongy and branched charcoal types, that's probably lower intensity, lower severity fire that's not getting hot enough to burn woody material. However, if we see a large scale shift to bordered pits or another charcoal type dark, which is hardwood wood material burning, we can see that maybe fires are hotter, more severe. They're able to burn larger, more dense material. Future works include, future directions include doing pollen analysis at these sites at a really high resolution to see what's going on with overall changes in forest composition, along with a bunch of other proxies that unfortunately I don't have time to go into today, but are really, really interesting. If you want to hear more, we can later. So what does this all mean in the face of a changing climate? Well, if we look at this June, July, August average temperature anomaly from 1895 to 2020, thanks to our climate reanalyzer, we can see that overall Maine's temperature is increasing. If we look at precipitation anomalies, we can see that while precipitation has remained fairly steady, we are starting to see large-scale changes in the 2000s. And this is really important because temperature and precipitation drive fire regimes. It affects the fuel loads on the landscape. While it looks like we're getting more precipitation, it's actually predicted to become less regular throughout the year. Maine has a humid continental climate. We get rain and snow consistently through every season. If that pattern shifts, we'll get periods of extended drought, which can let fuel loads dry out, which can lead to higher fire risks. So it's really important that we understand past fire regimes, their drivers, whether they were people or climate, and how widespread they were, so that we can understand what's going on today and make accurate predictions about what's going to happen with climate change in the future. I have many, many people and funding sources to thank for helping with this project and the development, interpretation, all of it. So thank you all for your time. And if you have any questions.
You said you're curious to know what Maine's fire history was like in the past, how it's predicted in the future, but if Maine is trending towards being much warmer than it ever was, how is knowing what it's like when it was wetter, how is having that information going to be helpful?
Because Maine was also really warm in the past.
What?
We've had periods of warm and periods of dry, although we need much more developed climate records for Maine specifically to see to what extent. But we've been through periods of warm and dry. Our fire regimes have changed. And if we look back at those figures of those patterns, during those periods of warmth, our fire records were actually lower, which is really weird. And we don't understand why. Based on the literature, it should be the opposite way around. So we need to understand why it was different to understand how our systems today are going to respond. But great question. Thank you.
The almost all sediment cores that pollen studies in Maine have a lot of charcoal in the period in the early Holocene, and it varies from site to site as you pointed out. And the species present are things like pine and birch, which are very well adapted to fire. So it all makes sense that there were fires in the region. Or regional hypothesis about why that would be is axial precession, because the maximum insulation in the northern hemisphere is highest 13,000 years ago, and then the next few thousand years, and then it switches to where we're going now, which has the lowest in a precession cycle. So I think in the big picture, that you think that is consistent with what you found, or are you exploring that? I just know from looking at lots of slides, almost every slide I look at is from the early 8, 9, 7, 8, 9, 10,000 years old, they're loaded with trouble.
Absolutely. No, I'm really interested in seeing why there's that shift, because while that does align with climate and what's going on with forest structure, we still expect to see that increase in charcoal during the mid-Holocene warm period, but we don't. So if it's not just about summer insulation, but also precipitation patterns and the temperature, then why aren't we seeing more fire when it's getting drier and hotter? That's the sort of thing that we have lots of questions. We have some questions. Okay.
Just as a thought, whenever it does get warmer, the Gulf of Maine gets warmer. When the Gulf of Maine gets warmer, you have more precipitation, which is what's happening today. The difference today might be that the climate is just much less stable, and it really only takes one serious fire to make a very big difference. So the explanation to the warmer period being drier could be the Gulf of Maine.
Yeah, and we're also seeing really weird patterns of the forest composition as well. Like we actually have a fair number of pyrophilic or fire riot species in Maine that seem to have been here for a long time. I mean, it makes sense post deglaciation with those lower fire return intervals. But why have they persisted until now? If we've had that humid continental climate, if we haven't had fire, if we don't have the lightning strikes to allow for that, what's going on with natural ignition sources? Is climate is lightning strike frequency decreasing now from what it was in the past? There are so many factors, there's so many questions, but yeah, if anyone is interested in talking about this later, I'm more than happy to dive into it. It's my favorite topic to talk. Okay, okay.
Thank you, Maddie. So Aaron Victor is sadly sick, so we'll be seeing this video presentation from the.
Hi everyone, I'm Rajma Bahadi. I'm a second year PhD student in plant science. I work in plant physiology lab, and I'm doing this presentation as a part of the Symposium for year 2023, and it's part of Climate Change Institute. I'm sorry for not being able to present in person because I'm currently in Israel as I'm recording this presentation doing my research here. So today I'm going to present on the topic temporal instability of the economic spectrum relationship among the genotypes of two temperate climate species. Before I move into the core concept, background information and everything, my presentation outline is going to be based on background information, method, result, and conclusion. Before moving into the topic, some of the key concepts that I need to clarify with you in order to understand this research topic is one of them is plant functional diversity. What is plant functional diversity? It's simply the range and dispersion of plant race within a community, landscape, or larger spatial scales that are functionally relevant for growth, reproduction, and survival, which are an important component of biodiversity. They're crucial for achieving local biodiversity monitoring. They're important for improving predictions on how future climate change will affect ecosystem functioning and ecosystem services. For example, if you look at the figure on the right, we have some of the plants that exist in rocky areas, some in a like an urban ecosystem, some in danger, some in the grassland. So plants are everywhere. The question is, why are they there? One of an important answer to the question is because of the functional trait or functional diversity that they have, they exist where they are. Another important concept is what is the economic spectrum. And the concept of this is very important in order to understand this topic because this is what I studied across different years in temperate climate species. That's what it is. So the economic spectrum characterizes a strategy for a faster, slow rate of return on carbon investment in leaves and has a further between longer lifespan and high photosynthetic rate. For example, there are plants or leaves that have a high metabolism rate but cannot live long, but then on the other side, we have plants that have low metabolic rate but can live long. So this trade-off is reflected by three key plant functional traits that are photosynthetic rate, land mass per area, and leaf nitrogen. If you look at the figures on the right, this is a 3D figure of how photosynthetic rate and leaf nitrogen are related to LMA. In nature, or the way it works is photosynthetic rate and leaf nitrogen is negatively related to LMA, whereas photosynthetic rate and leaf nitrogen are positively related to each other. So this trade-off between these three plant traits is what governs or characterizes a strategy of carbon investment in this. And it works as a general principle governing the development of three functional traits, which are a structure and physiological characteristics determining the performance of an individual and its response to the environment. So trait relationship really community assembly, ecosystem function across biogeographic regions and in response to environmental change. Now, why it is important, why do we need to study the economic spectrum trait relationship? Is my major study motivation came from, I looked at a number of hundreds of papers, and there are so many studies done related to the economic spectrum, and programs to a local scale in different linears, in different geographical regions, in different ecosystems ranging from food to woodland. But I found that some of the fundamental questions inequality remains unanswered, such as how to economic spectrum relationship vary across years. Like, are they stable? Are they unstable? Like, how does the economic spectrum relationship varies across the years? Because every year is different, temperature is changing, precipitation changing, climate change is changing, and environment is changing. To sum up. So the question is, how does the economic spectrum relationship varies across years with a changing environmental condition? It's something that we want to get answered through this research. Now we use this to test wildlife system as an appropriate system to test this. Why is because a little bit background on wildlife. If we go to the wildlife field and wildlife provide us another system, meaning that they are connected under the soil, the roots are connected under the soil. But then in the ground, if we go and look in the field, it appears as a mosaic of different colors. It's really pretty and beautiful. But then a question came to my mind, like if they're connected only with the soil, does it also appear similar above ground? Or why are they appearing in a mosaic of different colors? What is the difference? What is the variation? What is leading to be this? So I really wanted to understand the variation. So this is a unique natural semi-natural agricultural system to test this, meaning that wild populations are already there, but then farmers use this system to actually manage for crop growth and yield. And there are thousands of genotypes within a single farm, within a site. So sample size is usually very, very large. And like I told you, there are thousands of genotypes in one farm. So I think that this was a very, very appropriate system to test this. The particular study I to test whether the economic spectrum principle found in the given system, whether it's high into genotype and intergenotype variation, and to understand if changing environmental condition affects economic spectrum trade relationship and change widely common composition and structure over the years. We did the study in a Bloomington farm, Jones, which is a 2 hours drive from Orno. And we did a study in a 16 genotypes from 2 species, that's Vaccinum mysticoideum and Vaccinum megaloides, and these 2 species have been existing with us for a very long time, and they're most common most of the fields in Maine. And the study was done for 2 crop per cycle, meaning that wild communities usually have 2 years as 1 crop per cycle. So this study was done for 4 years. And 2 crop per cycle, and each year has 1 per year, 1 crop year, where in per year, the wild community grow their vegetative growth, and in the crop year they produce flowering fruits, where blueberries are harvested in crop year. So for 2 per year, 2 crop years, but that study was done for 2 crop per cycle. And a snapshot of how the environmental condition looked in those years, 2017, 2018, 2019, 2021, it changed the precipitation pattern. If you look at 2019 and 2017, these 2 years in Maine are very wet or wet years, whereas 2018 and 2020 they are relatively dry years. And the temperature pattern also looked dry in 2017, 2020, 2018, or in 2019 it was relatively fine. So I'm bringing this to a point. What I was showing is that we found a large temporal variation in leaf concentrates across genotypes. And then locus blueberries by protein morphology and synthetic traits, nuclear concentration, and structural and functional traits. Now, what that means is that I want to simplify this table. There are different functional traits, for example, photosynthetic rate, leaf nitrogen nutrient concentration, chlorophyll content, leaf vascular area, leaf size, structural traits. So I'm not going to go into the details of each and every trait and how they performed in each year when both the species were combined together and how individual species perform. But then if you look at just mass-based photosynthetic rate, like how it varied across the years. Like, for example, 2020 and 2018, so similar performance, but then 2019 and 2027 are different. Like, and same values for Vaccinum on the Mysticoideum vaccine methodologies too, like they're not same. But if you look at the difference percentage rate, 2019 stands alone compared to all other years. Like, so there's a lot of fluctuation even across years within a trade or even between the trades, or if you combine both species together, or if you look at the individual species alone, there's a lot of variation across the years. And we also found that some traits also vary by the crop growth cycle. Like what that means is I told you that there are 2 years in one crop growth cycle, like 2019 and 2020 is one crop growth cycle, 2017 and 2018 is one crop growth cycle. So 2017 and 2018, like the performance of mass-based carbon is same for 2019 and 2020, even though it's one crop growth cycle, it's different. And if we look at the prune years and the crop years, there's also variation. Like some traits vary by the crop growth stages, ranging from crop year and prune years. If we look at this, what I say, area-based photosynthetic rate, the prune years are different. 2019 and 2017 are different, significantly different. But then crop years are same, like AB. 6.91, 7.1, but they're not significantly different. There's a lot of variation across years. If they vary by the crop growth cycle, and they also vary by the crop growth stages, like the crop year or the full year. And our finding or an explanation to this is trait variation within locus fluidity is because of the cross-year variation and interest-stem variation within the genotype. Now, what that means is if you look at the variance partition analysis result, y-axis is the extent varies, and that is in percentage, and in x-axis is we have different forms of traits. So purple is percentage contribution of year, and blue is percentage contribution of species, green is percentage contribution of genotype, and red is percentage contribution of stem. So area-based photosynthetic is contributed highly by year across year variation, same with mass-based photosynthetic rate, LMA, leaf size. So across year variation is high. But then if you look at mass-based chlorophyll, like your stem variation is high. So, and then if you look at stem diameter or plant height, stem variation is high. So the main thing that across year variation could be because of across year variation, because of the environmental condition, and even the interstem variation, what that means is every individual stem, even within a genotype, is different. And that's what we think is causing the variation. To move into more details on how global leaf economic spectrum trade relationship deviates from global leaf economic spectrum relationship, we found that global leaf economic relationship trade relationships do not always hold across the genotype studied at a farmer site. Now, if we look at first half on left hand side and second half on the right hand side, first half belongs to Vexillum monstifolia and second half belongs to Vexillum metabolians. And then the first graph is the relationship of nitrogen and photosynthetic rate, and second is photosynthetic rate in LMA, and third is the nitrogen with the LMA. So if you look at all of this, and each dots are plotting of years, and on the background is a plotting of bird-net species. Where bird-net species is simply a global database for angiosperm species, but they're plotted on the background. And red line and red dots for 2017, green dots and green line for 2018, blue dots and blue line for 2019, and purple dots and purple line for 2020. So what I'm trying to show here is the relationship does not always exist. For example, there is only relationship of photosynthetic LMA in let's say 2019, but then there's no relationship all of the years. Sorry. And there is a relationship of photosynthetic rate with LMA in 2017, but then there is no relationship in all of the year. Whereas there's no relationship at all with photosynthetic rate and nitrogen. And if you look at Vexillum metabolian, there's a relationship in 2019, but then there's no relationship in all of the years. And if you look at nitrogen and LMA relationship in Vexillum metabolian, there is a relationship 2020. So the relationship does not always hold true. Like global economic relation do not always hold across the genotype studied at a farm site. There's a lot of variation going on. And another finding was that traits shift over the years that was driven by changing environmental condition over the years. What that means that if you look at the principal component analysis results, we have blue in 2019, green triangle is 2018, and purple circle is 2020. Like 2019 stands alone compared to 2018 to 2020. 2018 to 2020 are found at the active side of the BC, whereas 2019 is found at the positive side of the BC. And if you look at it further carefully, 2019 is traits are more related to rainfall or precipitation pattern. Whereas if you look at the traits in 2018 and 22, the traits are supported by the temperature, and they're more favored by the temperature. And if looking at how genotypes of both species perform, they perform differently. If you look at 2018 and 2019 here, like the red ones are Vaccinum angustifolia and blues are Vaccinum metalloides. Vaccinum angustifolia are located more towards the center in 2018 and 2020, whereas if you look at 2019, Vaccinum angustifolia and Vaccinum metalloides genotypes are scattered all around. Like they don't have an accurate pattern. So genotypes of both species perform differently in different years in temperature favor nutrient and structural traits in dry years, and therefore favor for synthetic and structural trait in wet years. So in the conclusion, what we found was that temporal instability of economic relations with robust covariance across a diverse genotypes without being related to high temporal and intra-genotype variability between the individuals of a genotype means variation between the stems, even within a genotype, and that relatively narrow range of traits covered at smaller spatial scales. And high temporal variation can be attributed to shifting environmental conditions across temporal scales, which highlights the vital role of changing environmental conditions in shaping functional traits and improving community composition. And cautions must be taken when interpreting the results of studies limited by a single year or single time point data to understand the influence of traits in effects of performance and cognitive change through time. And future studies should aim to uncover the role of changing environmental conditions in shaping plant communities by assessing intra-genotype trait variability across temporal scales.
All right, hi everyone. Thanks so much for being here. My name is Catherine Collins-Speed, and I am a second-year master's student in the School of Economics and a member of the Climate Change Institute. I'm also a National Science Foundation Fellow on the Systems Approaches to Understanding and Navigating the New Arctic National Research Traineeship. I'm presenting research today that I've done with Dr. Kathleen Bell, Dr. Tracy Michaud, Dr. Caroline Noblett, and Dr. Angela Daly, entitled Exploring Agritourism as an Adaptation to Climate Change. So just a little overview. I'm going to be giving some background motivations in my research question, talking about my main topics, which are tourism, economic challenges, sustainable development, and agritourism. Then moving into my methods of qualitative work and my results. So here you can see a picture of Kuyata, Greenland. This is the region in which we spent a month doing field work. So that region is here on the map of Greenland. For a little background, Greenland is the size of 4 Texases stacked on top of each other. There are 37 sheep farms in the whole country, and 36 of them are in this small area of Kuyata, which is blown up here in this fjord system. And just for a little more information, Kuyata is important also culturally and heritage-wise, as Greenland is 89% Inuit. And so this region has always been important because sheep farming is a major lifeway for the Inuit people in Greenland. And so trying to preserve the farming there is important. There's a UNESCO World Heritage Site there. So this is a huge cultural hub. So my research question is, what are the challenges farmers face when pursuing agritourism, and what can they do to be more successful? So what is agritourism? Agritourism is when people come and stay on a farm as kind of a vacation. They can help the farmer do some farm work and kind of learn alongside the farmer. It's really a booming industry globally. It's growing by like 20% per year in some countries. And it minimizes the negative impacts of tourists, especially in Greenland. The area we stayed had only 50 people. And there was one grocery store, it was open a couple days a week for a couple of hours. So when people come and stay, they can really overwhelm the country or the cities and towns quickly, wiping out the stores. And when we went, we were 20 people, we were half the size of the whole town itself. So any tourist at all can be a serious impact on a town. And furthermore, when cruise ships come, the people who are on cruises don't spend long enough or spend enough money to really be beneficial. And the dock fees of cruise ships don't even go to Greenland, they go to Denmark, as Greenland is owned by Denmark. So agritourism can enhance the quality of life for impoverished people and communities, as rather than spending money on cruise ships, people are spending money, putting it in the hands of the farmers and in the hands of the people in the communities. And so this revenue can be really useful to farmers to diversify their income. As right now, they're only bringing money as farmers, but then they can bring in money as tourism providers as well. And there are also non-financial reasons, which we will get into. So why is this even important? Well, we know that Greenland is warming at 4 times the rate of the rest of the world. And tourism really has not been well analyzed as an option for the Arctic as sustainable development goes. So that's what we're looking into. And like I said, tourism can generate economic activity without damaging the systems. So currently tourism numbers are rising in Greenland, but like I said, tourists don't really stay long enough. But by 2040, the Greenlandic government predicts that tourism will reach 74,500 people on land and 40,000 people on cruises. This is significant given that Greenland's population is only 56,000 people. So here we can kind of see tourism international flight by the numbers. So as you can see, it's been increasing. We had the drop in 2020, guess why? And then it's going right back up. Cruise passengers are really increasing here. And so we're kind of trying to shift that tourism slightly away, more towards agritourism than cruise tourism. So how is sustainable development part of this? Well, sustainable development is development that fits the needs of the people without compromising the needs of the future. Sustaining finite resources, balancing economic needs, social needs, environmental needs, peace, security. And then the UN has actually outlined some guidelines for sustainable tourism itself. So, and that includes the optimal use of environmental resources, respecting the authenticity of the communities, conserving heritage and values, and ensuring long-term operations that benefit everyone. So that's kind of how we're trying to make sure that our agritourism fits into sustainable development. So what are we doing? What is this research? So I'm using qualitative research methods, which are slightly unusual for an economist. We're doing co-production and co-creation, which means that rather than saying, we have this idea for you, we're going to bring it to the people of Greenland and see how they react. We went to Greenland and said, hey, how can we help you? What do we need? And throughout the whole process, we've been going back, talking to the stakeholders and saying, hey, is it still benefiting you? Is this still helping you? Because what we don't want is to be pushing our agenda on the Greenlandic people. We've been conducting interviews. As you can see, we did some in Maine and Arkansas, which I'll talk a little bit about, and then coding for themes. A big part of research in Greenland is research fatigue. And so in the Arctic, as there is climate change, scientists love to talk about climate change. They love to interview people about it. And we see that people in Greenland are really tired of being interviewed. So rather than asking every farmer we could find about climate change and agritourism, we talked to a couple farmers and then came back to Maine and talked to agritourism providers in Maine to kind of see what their best practices and lessons learned were. So we could bring those to the Greenlandic people and say, here's what we've learned. Maybe this could help you. I also completed an internship this winter on a farm in Arkansas that does agritourism. They're a leader in agritourism. And so that was a participant observation to learn even more. So we did 7 in Maine, 2 in Arkansas, and only 1 in Greenland. The emergent themes that came out of my research were motivations, challenges, and keys to success. So let's look at those. The main motivations were education. So farmers wanting to teach other people about farming. Social interactions. Some of the farmers said that that's really the only interaction they get all year long is when people come visit their farm. So it's huge for them to connect with the world. Financial, of course, people pay to stay on the farm. Their passion, they love farming, they want to share it. Customer driven. So a couple farmers said to us, I didn't even mean to offer agritourism, but people came to the farm and said, hey, can we sleep here? And it began working out. That's happened a couple times. Like I said, sharing, and then self-sufficiency. Some challenges have been biosecurity. During the avian flu, people would step on one farm, step on another. Now that farm has avian flu also. Farming takes a toll on your body. It's also not profitable. Almost every farmer I spoke to said that farming does not make any money. And only when they have implemented agritourism did they begin to even break even. And then boundary issues and liability. So liability has been an issue when people come, stay on the farm, get hurt, and the farmer doesn't have insurance because it's expensive or it's too difficult to navigate. They just don't understand how to even begin the insurance process. It's very complicated for them. There are all these different needs insurance wise if you have a farm. And then boundary issues have come up when people don't understand the farm is one thing and the farmer's house is another. You can't just walk through the farmer's house all the time. So that's been an issue for a lot of farmers engaged in agritourism. And then keys to success. So these are things that we said to the farmers, what's worked for you? What are your lessons learned? They've said that collaborating with other farmers has been huge. So once a farmer finds their niche and says, okay, I do honeybees, they talk to the farmers in their region, everyone finds a niche, and then they can build kind of a tour. And so they call this keeping heads in beds longer. So when you stay on a farmer's farm, you do what they do, you can do the honeybees for a day, and then you can do the flowers and do the potato farms around. And so make kind of an agritourism tour. Resources, so the Maine Fiber Tour has been useful, the Sheep Farmers Association, utilizing the resources you have, especially the University of Maine Cooperative Extension has been great for a lot of farmers. Building around tourists is something that I didn't expect to hear about. But some farmers have said, yeah, we built our milk stand, it's kind of a pain in the butt to even reach the cow, but it means that people don't get kicked. So keeping the tourists safe before making the farm easy for you has been important for some farmers, especially in terms of the liability we spoke about. Starting slowly and making sure things are profitable before moving on to the next things. We don't have not enough manpower. Technology, and this isn't anything crazy, this is FaceTime, Zoom, the internet. These have been huge helpful things for farmers as they're marketing and connecting with the people who are coming to stay. And lastly, personalization. This came up a lot when we were talking about selling wool. Farmers said, oh, if I'm selling a skein of yarn, it can be $7. But if I'm selling a skein of yarn with a picture of the sheep that it came from, the sheep's name, age, and story, that can be $20. So personalizing something like that with the story, is really helpful. So why is this important? So during my time in Arkansas, I identified several main challenges for those farmers, which were poor internet connectivity, which is not unusual in a rural area, time and labor shortages, which is not unusual if you're a farmer, and a lack of technological literacy. So from that, we're trying to encourage our stakeholders to look into mentoring or interning programs, which is what I did. I went and they give you room and board and you help them, especially if they're great at farming and you're good at social media. You can kind of share those skills with them. Technology classes, and even if that doesn't mean people come in person to take a class, but even if you put out a video, hey, here's how to use Facebook. And then improve connectivity, which could be great. We're already seeing some progression toward that in Maine, so that could be helpful in Greenland. I'd like to thank CCI, Sauna NRT, Innovation South Greenland, Dogwood Hills Guest Farm, my interview participants, and Mavis. Here are my references. Thank you. Any questions?
Are there competing tourist industries in these areas you've been looking at that, like agritourism, may try to draw some of those tourists out into the rural countrysides, or is this really the focus of tourism?
It's a pretty different group of people. It's a pretty different demographic who wants to be on a cruise and who wants to be on a farm. So if anything, they're drawing from the explorers, the people who want to be hiking, the people who want to be ice climbing. They definitely are trying to draw that different demographic, and it's expensive. It's about $1,000 a week, so it does require a demographic who has that kind of disposable income. But at least in Greenland, they said that agritourism is a huge part of tourism marketing itself. So it's really not drawing away as much as it's adding a new facet.
Just a quick question, that I think the title of the presentation was exploring agritourism and an adaptation strategy, right?
Yeah.
And I just, I agree, very well could be, but your presentation is primarily focused on like, what are some of the challenges to agritourism?
Sure.
What does the literature say about, is agritourism or any form of tourism really a viable strategy for climate adaptation?
Yeah, absolutely. So especially in the literature, they look at it as opposed to mining. So mining could be a way to make money, as Greenland's trying to potentially separate from Denmark. They're trying to make enough money. And as for the farmers, they can't really afford to continue farming as drought makes it more expensive. And so there's the option of mining, but that can really make the water unviable for farms. And so now they're thinking, okay, let's try to bring in money with agritourism. So that is in literature an option.
Thank you.
From which countries are most of the tourists coming? And is there thought of expanding the marketing of this?
Expanding, sorry, can you explain?
Expanding the marketing of agritourism
Sure.
to other countries and other groups than those who are coming now.
Absolutely. So a lot of the people who come are from Germany, are from Sweden, so they're in Europe. Actually, fewer are from the US, so it's mostly European tourists. Germany is the biggest group. Marketing, yes. Innovation South Greenland, who are one of my stakeholders, they're definitely looking into increasing their marketing. But first they need to kind of get agritourism up and running, because right now only a few of the farms are engaged in agritourism, so we don't want to overwhelm them. Anything else? Thank you so much.
Good morning, my name is Sydney Barada. I am a second-year master's student in the School of Earth and Climate Sciences, working with Kristen Schild, as well as Lee Kerboss and Emmanuel Boss in the School of Marine Sciences. And my work is not straying too far from Kate's. It's also focused in South Greenland, specifically quantifying rapidly changing tidewater glacier systems. This thing exists. So just to kind of put us in context of the system itself, it's a system. It's everything's interconnected, everything works together. So what happens in the atmosphere affects the glaciers, affects the oceans, and then the conditions in the ocean affect things like the biology and the primary productivity. And so I'm going to focus, for kind of the scale of my research, is going to be on the sediment plume component, which is kind of the middleman between glacial melt and the biology in the fjords. And this is because sediment plumes are really important. They not only, well, they're an indicator of glacial melt, but they also act as a layer that prevents light from penetrating the water and therefore inhibiting phytoplankton growth. And so this is a big problem in South Greenland. We see through remote sensing processes that all of these glaciers are in different stages of retreat. And so when I say stages of retreat, I'm not talking about seasonal variability. I'm more talking about where the proximity of the glacier terminus is with respect to the fjord. And so you can see that on the top, that's an active tidewater glacier in the blue, and then the purple is a long-standing land terminating glacier. And then the red box, which is my fjord of interest, Kallarala-Ima, is actually in transition. And you can see that these all have different retreat rates. And I'll talk about what the difference is between those. So a tidewater glacier is what it sounds like. It's a marine terminating glacier. The water is in direct contact with the ice, and the ice is melting at all different depths, entering the water column all throughout. And so this glacial meltwater is very nutrient rich. It also carries sediment. And so the big thing, oh, and it also has icebergs, the glacier does. And so those act as little point sources of freshwater melt and injection. But the big thing here is the subglacial melt. What happens through the water column? This water is very buoyant and it is upwelled to the surface, carrying all those nutrients, and therefore it is very productive in these settings. Conversely, a land terminating glacier, also what it sounds like, the glacier has retreated back, and now the only glacial meltwater entering is over the land as a river. And so as a result, you get these very buoyant sediment plumes. But the big thing is you don't have any glacial melt entering at depth. So you don't get any of these nutrients being upwelled. You only really get circulation from things like wind-driven circulation and tides. So these aren't as productive, typically less productivity in primary producers. But again, what I'm going to be focusing on here is the sediment plume component because of its ability to obstruct light. So what we expect is that primary producers will actually decrease as tidewater glaciers continue to retreat and sediment plumes increase in concentration. And so this is a really good example of a sediment plume. You can see it's very clear. You can tell it's there. It has a different spectral signature, which makes it really great to calculate through remote sensing methods. So overall, my research goal, how do fjords respond to retreating tidewater glaciers? We need to extend that back in time, and we can do that with remote sensing. But the catch is that it needs to be calibrated and validated to do that. So we use field measurements. And so last June, we went to Greenland and collected 47 in situ samples, mostly in Kallarala-Ima. And we were lucky enough to have 20 of those corresponding to days with little clouds and satellite overpassing, which makes it honestly really good. We also collected temperature, salinity, suspended sediment concentration, which is the big one, and then relative chlorophyll fluorescence to get an idea of what it's like. And so again, sediment plumes have a different spectral signature. So as that sediment is buoyantly suspended in the water, it strays from reflecting blue light, which is the open water, and it actually starts to go into the red and even near infrared if the concentrations are high enough. And so you can see that in a measure of suspended sediment in milligrams per liter. And so we can use a relationship of combining the red plus the near infrared bands to account for that shift. And then we can develop a relationship between those when comparing it to our in situ suspended sediment concentration samples. But we have a huge gap in our data. So we were really lucky to be able to get all these first measurements. These fjords have not really been explored ever. So this was a really good first step. But we have suspended sediment concentrations from both end members. The low, which we saw in person, it was open water, no sediment, really. And then the higher values, which was right in front of this land terminating glacier, that big red plume right there. And so we know that was a plume, so we can use that knowledge along with the literature to kind of develop a threshold to delineate what the plume is. So we can define that relatively as 12% reflectance and above being a plume. And so again, we have this gap, but it's okay because once we fill in the gap, which we have another field season planned, so hopefully we can fill in that gap a little bit, then we can get absolute values. But for right now, this is really good because we can just get relative values, which then apply that relationship later on when we have a full comprehensive data set with no gaps. So preliminary results, I'm still working on it, but we know that these glaciers are retreating actively. They are in all different stages of retreat. And right now I'm still calculating sediment plume concentration over time. But we don't know what this will look like. From preliminarily, from looking at the data, it does look like at this land terminating glacier, sediment plume concentration is the highest given its higher reflectance values. But I'm really excited to see what the response time may be, how it actually retreats, how variable they are. So there's a lot of questions, but I think, next field season, we'll be able to kind of answer some of these questions and also fill in the gap and get an accurate representation of what's happening in these fjords, especially because indigenous communities in this region rely so heavily on the food and marine mammals and fish that come from these fjords. So it's a really important place. And I just want to thank my committee, especially Kristen, and my sampling team in Greenland, as well as NSF SONA's NRT program for funding this research, as well as Task Meet for housing. Thank you. Any questions?
See, what do you actually do?
Yeah, so here. Yeah, so the validation is essentially making sure that what a plume is within the imagery is actually a plume in real life. So that's kind of the validation portion, and then the calibration is using this little relationship right here. Kind of plug in the estimated suspended sediment concentration to achieve an absolute value. Yes.
So when you're wanting to fill in this gap of data, do those values actually exist in the natural environment and you just weren't able to capture them, or is it that only the two end members?
They do exist. Yeah. So I forgot to mention, we were doing all of these samples by kayak. So we weren't as efficient as we could be. So we were only also looking in this fjord alone. So it seems like we were either in open water or in like the deepest concentrations. So we are planning next year to do kind of a comprehensive grid throughout the whole fjord and then also explore other fjords to get a wider range of data as well as fill in the gap. Sweet, thank you.
So Kit is sadly sick, so we will move on to Avery.
All right, good morning, everybody. My name is Avery Lamb. I am a second-year PhD student with Jasmine Sorrows. And today I sort of want to walk you through some of the challenges we've been facing when we're trying to expand methods for historical cyanobacterial reconstructions using sediment DNA or SED-DNA and photosynthetic pigments. So it's pretty well established at this point that cyanobacterial harmful algal blooms or cyanohabs are increasing in prevalence and persistence as climate is changing. In our, and this is a concern a lot because of the production of harmful cyanotoxins. The most common cyanotoxin reported in the US is microcystin. In our higher nutrient systems, our eutrophic and heterotrophic systems, microcystin is often produced by Microcystis and Dolichospermum species. However, in our low nutrient systems like we have in Maine, Gliotrichia is often our genera of concern. In fact, Gliotrichia has already been identified in 19 of 22 lakes that were surveyed in Maine in 2012. You can see this in the map on the right. The darker the circle, the higher the concentration of Gliotrichia in that water sample. And this is interesting because Gliotrichia has a neuroplanktic life cycle, which means it spends part of its life cycle in the water column where it can bloom, but then in the fall and winter, it overwinters in the sediment as an acne or a vegetative resting cell until following spring. This means that environmental conditions such as light and temperature in that winter-spring transition can really affect the recruitment of these actinides from the sediment into the water column. This can really complicate things in Maine, where we've already established that Maine is warming. But when you dial in a little bit closer, winter, so your December, January, February months are warming at a higher rate than some of your other seasons. So if we're warming in the winter, then this could really have implications for this Gliotrichia life cycle and these harmful cyanobacterial blooms that we could be seeing in Maine. Although we've established that these things are increasing, the specific environmental conditions that can trigger cyanobacterial harmful algal blooms are really poorly understood. And part of that comes down to differences in interspecific responses to warming and nutrient concentrations and all of these things that we're concerned about. The fact that we generalize climate parameters and we have insufficiently long time series. So the overarching concept of a lot of my dissertation work is to look at sediment cores from a variety of lakes in Maine that differ in nutrient status and differences in warming to be able to sort of investigate the connections between warming winters and cyanobacterial blooms, especially Gliotrichia in Maine. And to do this, we use multi-proxy reconstructions in sediment. So I'm specifically looking at photosynthetic pigment records, in addition to sediment DNA and long-term temperature records to be able to reconstruct these conditions. So photosynthetic pigments are the compounds that primary producers use to photosynthesize. These chlorophylls and carotenoids can be more general, so think chlorophyll A, the thing that we all learned about in our basic biology classes, that are more of an indication of overall primary productivity in the system. But then we also have more specific compounds like aphanizophil and diazoxanthin that can be indicators of specific types of algae. For example, diazoxanthin can be indicative of diatoms, canthaxanthin can be indicative of cyanobacteria. So if you identify, measure, and quantify these over time in these sediment cores, then you can get a pretty good indication of how communities are changing over time. This is a pretty well-established proxy in the paleolimnology world. However, this project also integrates a newer proxy, the SED-DNA, that can sort of be studied in two different ways. One, you can measure the SED-DNA via quantitative PCR, qPCR, and this gives you quantitative measurements of your cell or your DNA counts of a particular target species, as opposed to something like metabarcoding, which gives you a more holistic presence absence indication in the sediment. So even though this is a really exciting proxy, it's again much newer than something like photosynthetic pigments. So we already have a good estimation of how communities can change over time with pigments. Why would we even add SED-DNA into the picture? Well, you get a much higher taxonomic resolution than photosynthetic pigments. Like I said before, pigments classify more of a class of algae, so diatoms, cryptophytes, cyanobacteria, and with SED-DNA, you can get something closer to the genera level. You can also provide estimates of species richness and diversity within communities that pigments cannot provide. So we're really circling back to this big unknown piece of differences in interspecific responses to climate change. So it's complicated. There's a lot of challenges in trying to establish this as a common proxy in said DNA. Part of that is more on the theoretical level. We don't have a very clear understanding of taxonomic and depositional qualities of said DNA in the environment. This is a theoretical figure from Houston and Lopez that's in progress. And if it looks complicated and overwhelming, good, it should, that's the purpose. There's a lot going on in this aquatic environment that we're not quite sure how that affects how the said DNA is deposited and preserved in the environment. You have water characteristics, like of the lake, like residence time and flow rate, but you also have environmental characteristics like temperature, UV radiation, and pH, and that's just in the water column. Then you get down into the sediment matrix where you introduce things like oxic and anoxic conditions that can help to preserve the said DNA, and or microbial activity that munches on the DNA and can make it a little more complicated. So given all of this, we're going into this understanding that there's still some unknown factors and maybe some interpretation that needs to be conservative. All right, but what about practically? Well, it's very common in DNA analysis to sterilize your equipment completely before you go out in the field to collect samples. For this DNA study, we use the very common method of 10% bleach to sterilize equipment, to sterilize all the little disposable things we use, and then rinse it very well in water, pack it up, and do our best to remain sterile in the field. Here are two very preliminary pigment figures from some of our first cores that we took using these methods. So on your x-axis is your concentration of different pigments, and on your y-axis is year, proxy for depth here. There's a lot going on, but you really don't need to know all that. I really want you to just pay attention to the very top here. On the left-hand figure, you can see that the pigments are decreasing at the very top. Now, if you're familiar with photosynthetic pigment records, you expect the very top to be the highest in concentration just due to degradation processes alone. That's not what we see here. They're markedly decreasing in the top. Then in the right, not only are they decreasing, they go to 0. Now, if you were to just look at this figure without context, it looks like this lake is dead. Spoiler, this is Sebago Lake, and I can assure you that this lake is not dead. So red flag, something is wrong. So after doing quite a bit of investigation and some testing between different sterilization methods, we realized that when you try to do concurrent quantification of pigments in DNA using this bleach sterilization method, even when we rinse well, there's some interference there with our pigments.
We've also fielded unique public opinion research in those 7 states, and we'll do an analysis of projected drought conditions thanks to the University of Maine's climate reanalyzer, and there'll be some discussion about the possible policy and political implication that worsening drought might bring to that region of the United States. At the heart of the third case study is the question, what drives voter decision-making specific to climate change? Jonathan Haidt's moral foundation theory suggests that we each have innate values, or what he calls intuitive ethics, or basic moral beliefs about right and wrong that we use to ground our judgments and decision-making, and that these foundations are unique to each of us, and that they instinctively drive decision-making. Haidt's hypothesis then suggests that liberals and conservatives use different set of values when making decisions. As someone who has worked his entire life in the political arena, the idea that there was some secret sauce in terms of messaging that might help persuade voters to prioritize climate change and obviously other issues was too much to pass up. The research specific to this chapter of my dissertation repackages the lessons and language of Dr. Haight's original research to test the core hypothesis in the context of climate messaging and modern partisanship. In addition to my committee advisors that you saw on the first slide, there's a long list of folks that I need to thank. This is an ongoing effort, and people have been absolutely wonderful. Here are just some of those folks. I'm sure I've missed some folks. If there are any questions, I'm happy to take them now. Okay, thank you very much.
Hold on a second. This is Cindy Eisenhower. Can you hear me?
Hi, Cindy, how are you?
Hey, can you just talk for a second about why you were looking at PFAS concentrations in the water? How are you linking that to climate change?
Say it again, Cindy, I'm sorry.
How are you linking PFAS concentrations to climate change?
Well, obviously, the meltwater, the rising temperatures, as Kate was talking about earlier, the rising temperatures is obviously causing the Greenland ice cap and the glaciers around the ice sheet to melt at ever increasing rates. The chemistry of that meltwater is obviously very impactful on a number of different things, not the least of which is marine health and human health. So that's obviously at the core of what we were looking at.
And what's the source of the PFAS? Do you know? Is it land
Well,
fertilizer?
The potential source is, I mean, the atmospheric and ocean transports. I mean, what we know is that these chemistries come into Greenland from very, very far away and are transported either atmospherically or through ocean currents, or obviously transported through the clothing that people wear or the products that we use.
Okay, thanks.
Sure.
All right, let's hear it one more time for Doug.
Thanks, everybody.
So now for our final presentation of the morning session, we have a talk from Eric Brown, which is a video presentation.
This is Eric Brown coming through from afar. Obviously, I'm not there in the room with you right now, but I'm about to be taking part in the symposium anyway. I'm going to talk to you briefly today about the use of correlative modeling to dive into the climatic niche and habitat suitability of tropical species of mammal that have historically been understudied or cryptic or otherwise difficult to ascertain ecologically. In particular, I'm going to talk about two species of tree shrew common to the island of Borneo, the large tree shrew and the lesser tree shrew. Tree shrews, like most mammals, are vulnerable to climate change. For the most part, tree shrews are probably most affected by habitat degradation and fragmentation, loss of resource availability, but things like increased global temperatures, increased frequency of extreme weather events like drought, irregularity of precipitation, excessive precipitation, flooding, mudslides, and things of that nature, very likely will impact and have impacted tree shrews on the island of Borneo. In particular, I'm interested in the tree shrews' regulatory capabilities in the context of all these climatic changes and downstream effects. As a group, tree shrews are only contained within the order Scandidia, which is endemic to subtropical and tropical South Asia. Their entire evolutionary history, about 50 years, a million years, has been contained within this region. And tree shrews are a very interesting clade for a number of reasons, that being one. But they also are a great opportunity because they are very much understudied as a clade. Their ecology and life histories are very much poorly understood, with the exception of the northern tree shrew, which is pretty common laboratory animal. They are phylogenetically proximal to primates, which is another intriguing point and opportunity to study a number of things that may not be realistic with primates, but evolutionary questions are one of them. And morphologically, they are very similar to social media forms in the literature. The one that is often called on the Brudinger, the hypothetical mammal that morphologic, like tree shrew, elongate rostrum, elongate the long skull, and makes points at comparison. This was and mammal. It's also climate. Okay. The chocolate baked tree shrews very much resembles, similar to the climate of the mid-Jurassic that well, same type of environments, but the choose a unique model for fish.
They don't have an idea about how to resolve that.
He's in a very remote place, so he probably does not have a good internet connection.
Yeah.
I'm not sure that much can be done.
This is a pre-recorded.
Yeah, this is pre-recorded.
Pre-recorded?
Yeah, he did post for a while.
All right.
When he was talking, it was
Sounded like
nothing nice.
Yeah.
Right. I don't figure it out.
We just haven't had that problem with any of the previous videos, so I'm kind of curious.
But it might be where he was when he.
I mean, it was still playing though, the number was.
Yeah.
Seconds, even all of us stuttering a bit, so.
All right, I'm gonna press play and let's see. Let's see. if this works.
And you are on 10 minutes, right?
Also.
Yeah, so this is like this would work even if we weren't on Wi-Fi. All right.
We may just not be able to
Yeah.
finish this one.
If unless anyone has an inspired idea, I think we're gonna have to declare failure here.
Try fast forwarding a little bit and see
Yeah.
if there's a better.
See if there's like a smoother part.
Figure in the left, this geographic representation, these hash lines represent the IUCN range of species. And this solid coloring, the whitish light blue is low suitability for the like on the island of Borneo, and dark blue being high suitability. And we see that there are some regions that are highly suitable for the tree shrew species. But we also see in one part that there's no overlap between the IUCN range and the suitability. So, of course, this model has limitations. And this is something worth investigating to see what geographically or artificially might be here, keeping tree shrews from occupying this area. And interestingly, precipitation metrics seem to be the most important variables to predicting where our tree shrews are in Borneo. The wettest month in particular contributed most to this model and isothermality has some influence, which is the temperature variation per day versus the temperature variation over the course of the year. But temperature metrics at large had no considerable contribution to the model of the large tree shrew. Similarly, for the small tree shrew, the lesser tree shrew, precipitation metrics, most important, especially the wettest month of the year. We see the IUC range is the entire island, and there's much more suitable habitat for the lesser tree shrew. But temperature variation contributed much more compared to the large tree shrew, especially seasonality and isothermality. Next step for this is to continue catching tree shrews. And here on the left, I've got a large tree shrew that I caught about a month ago, and to continue running respirometry experiments to measure resting metabolic rates at various temperatures to get a sense of how expensive it is to exist as a tree shrew at different temperatures. And then to also begin radio coloring and inventing biomarkers in tree shrews that measure core body temperature and accelerometry, so that I can get a sense for where these individuals are nesting, when they are eating, when they are foraging, when they are resting, correlate with environment temperatures, course of the day, and ultimately all together into a metric model, clear mapper model, which takes into for thing and other very most important mammals, and spits out so this definitely can be applied to past and future climate scenarios, and maybe even hypothetical instances for mammals like Schrödinger. And here's some other shots from what that looks like, doing some morphometric measurements. There's a little ear tag for identification of dogged out tree shrew getting weight in the lab, and upper right corner we got a squirrel sleeping, but that's basically what the respirometry, the measuring of metabolism looks like. And then bottom one is the inside of the chamber. And I'd like to thank IBEC at UMass for hosting this work. Laura Budino, my 2022 RU students, and Dana Seth for funding this work.
Well, thank you guys for bearing with our various challenges. We're going to break for half an hour and reconvene at 10:45.
little people.
Okay,
So there we go.
no worries.
Thank you.
Yep, so the question then is, how do we ensure that parties' commitments are fair? How do we ensure that we don't have people totally free riding the system and emitting way more than would be even possible under a 1.5 degree scenario or even a 2 degree scenario? So a lot of people have argued that Paris did not solve any of these long-standing problems between the developing and the developed countries. It didn't address issues of justice, but rather it kind of kicked them down the road. And so a lot of us have been asking, like, where's it going to land, right? When is it going to arise again? Well, here is where, let me introduce the global stocktake. So one of the mechanisms of Paris was this idea that countries would submit their NDCs, and every 5 years, they would go through this collective process of aggregating them and then taking stock and seeing how we are doing, right? Well, they agreed to that in Paris, but they said that it was going to be conducted in light of equity in the best available science. But they didn't say exactly how it was going to be done. So over the last 3 years, they've been in this process of like figuring out, okay, how are we going to take stock? How are we going to account for all these emissions and where they're coming from? And so what I've been doing is I've been observing these negotiations and participating in some of them since Paris. And so I want to ask today, based on what's happening in the design of the global stocktake, what is the best available science when we're thinking about equity? And I'm engaging in a theoretical debate that comes largely out of political science and international relations with about this idea is, should science play a role of heating up politics? So increasing the politicization of climate change, or should we try to cool it down? And interestingly, scientists differ on this, right? So we have internationally renowned political scientist Robert Keohane, who's argued that we have to cool it down, that science should be actively objective, neutral. We need to present science that doesn't engage in these politics of burden sharing in order to get collective action and consensus. Other critical scholars completely reject the Cartesian dualism that science can be separated from politics or morality or ethics. And if instead said that what we need to be doing to ensure the success of the Paris Agreement is actually keep those arguments up. So I wanted to engage with that question. So what I've been doing is I've been observing at the Conference of Parties, which is essentially when all the parties of the UNFCCC meet to negotiate climate agreements, about 24 days of observation in total. And I also was really fortunate to get to actually participate in the technical dialogues of the global stocktake in Egypt this past at COP27. So what I did is I built transcripts of all negotiations of the GST. I also downloaded all party inputs. So every country that has put in an input to the process, I downloaded all of those and thematically analyzed them all. So I have a lot of text. So what I found is that experts have weighed in on how do we account for equity. They've put forward a lot of different proposals, and some of those proposals get taken up by the negotiators. So by the Saudi Arabian delegate, by the China and the G77, and they become really political technologies. So here's what I found is there are a lot of claims or proposals that are based on what scholars would call false equity, right? They don't actually do anything to improve equity between developed and developing countries. Largely, this is grandfathering, where developed countries like, for example, you're not supposed to name names in this types of research, but I will. Canada right now is really active in this concept of grandfathering, right? And they use equity to say it. They say that because we need to have just transitions for our workers who've been in the fossil fuel industry, we need to start with the same allocations we have now. And then essentially like the developed countries tailor down over time until we get to like a meeting point, the convergence point in the future. Other people talk about low cost pathways. So somehow it's equitable if it doesn't cost very much. Other people talk about reductions in carbon intensity. These are considered false equity claims. Most folks who are concerned with equity use these 4 indicators. So one is equality, and this is almost always based on the fair shares per capita framework, where it's per population, right? So, and as you can imagine, that type of an equity metric is going to advantage countries like India, who have large populations, very little long-term responsibility. Need, this is based on the right to development. So this idea that just to meet basic needs,
there actually needs to be more emissions in that place to make sure that we get to kind of a level playing field. Capacity, this is the ability to contribute, and it's almost always based on GDP. And then responsibility. So this is the degree to which parties are responsible for climate change. Some of them are done cumulatively, some of them are done at a snapshot in time, but most of them are based on cumulative emissions. So this is all coming out of science, right? Scientists are putting forward these proposals. And the problem is that oftentimes they're done without any sort of recognition that they're political, right? They're presented as kind of objective, neutral science, numbers, pure numbers. But then they get taken up in these, I keep forgetting this is, why don't I just close this? I'm not using it. They get caught up in these political spaces, right? Where the science itself becomes politicized by the negotiators. So I want to just share with you a few, this is just a small snippet of some of the party submissions and or party statements during the COP27. So Saudi Arabia is arguing here both a responsibility and a need-based framework. They say IPCC data says that we need global pathway for 1.5, but does not take into account historical emissions or the right to development. This creates a discussion where equity and science are pitted against each other, and then more pressure is placed on developing countries to act based on urgency. So we need to change how we drive the conversation. We need to talk about the methodologies. So already Saudi Arabia is reacting negatively to AR6, which had just come out a few weeks before. The EU speaks right after Saudi Arabia. And this is Frank McGovern, who is a really nice guy. And he directly looks at Saudi Arabia and very pointedly says, I want to comment to Saudi Arabia that the IPCC is very clear that we can only emit so much. Leaving it there. EU sees equity as fundamental to this process. We want to avoid a reductionist approach to use equity to achieve things that won't help us in getting to that 1.5 degree goal. It is so powerful if we use it well, but if we use it as a barrier, I must have missed something there, sorry. It doesn't mean that we're ignoring the past, but that we need to look to the future. And one of the interesting things about the climate negotiations is that people often use language to signal certain things. And so when people say we need to look to the future, they're talking about grandfathering, almost always. India says, we lament that the IPCC does not integrate issues of equity into their scenarios. You cannot tell a developing country that you're going to remain at low levels of income. Equity considerations cannot be outside these scenarios. This does not consider past emissions or the right to a fair share of the carbon budget. They ask from us to forego the use of domestically available resources, but we have very vulnerable systems. We have limited financial resources. And then finally, Australia is arguing based on capacity, right, which would largely be based on GDP. And they say equity is a contested term, they recognize. How should we use it to achieve 1.5? It's a spectrum. There are countries that don't fit well within the Annex 1, which is developed, and Annex 2, developing dichotomy. There are countries that are not developed, but have higher per capita emissions and income. We have to instead think about how to act based on capacity to act. So you can see that these various scientific proposals that have been put forward from scholars from around the world have been deployed in very political spaces. But what I've found, and this is based on other people's research as well as my own, is that of those proposals that are put forward, those that claim neutrality, they're meant to cool down the debate, right? They're meant to reach an area of consensus to not kind of inflame those discussions between developed and developing countries, but that has largely backfired. When those types of scenarios are put forward, they oftentimes ironically heat up the debate because people get mad at the scientists, people get mad at the IPCC. So here's just one really famous example. This is called the Bali box. Where without any discussion about assumptions about when mitigation commitments began, without any discussion of what the political implications of this are, this box was put forward in AR4, with just these kind of clear, Annex 1 developed countries, non-developed countries, what they were going to have to do by 2020 and 2050 in order to reach these different scenarios. And it's very plainly stated, right? These are the numbers. This is the science. And this sparked significant outrage. And actually, a lot of people have said, pulled the negotiations back several years because people were so upset about the science manipulating the kind of politics of this. So I want to I had something I wanted to read to you. Yeah, I'm gonna be good. So I am arguing based on what I'm observing in the meetings and based on a lot of other kind of documentation in the empirical record of this, that in the case of equitable burden sharing, all science is political, right? It's impossible to separate the science from that politicization that is about, like, essentially, how do we make sure that the remaining carbon budget is shared in a way that people think is credible, is legitimate, and builds trust in the process rather than undermining it. So the best science can only really claim transparency. So we need to be careful there. And I wanted to just leave you with a reference to my title. So this is actually in the technical dialogue of the global stocktake in Sharm el-Sheikh. And the woman from Antigua and Barbuda had just stood up and said, we don't want just numbers. We don't want just the hard objective facts. We want just numbers that tell us about who has the right to development and who has to take responsibility for climate change. And interesting enough, people never clap when other delegates are speaking, but here you can see several people decided to clap for her. So anyway, this is just kind of an invitation to all of you who do work on mitigation and burden sharing to think about how we can, the best science can integrate the politics and the morality and the ethics of how to achieve a global stocktake that works and a Paris Agreement that's successful. So thank you, everybody.
Maybe you'll have 2 minutes for a question.
Yeah, Dan.
So COP28 is going to take place in Saudi Arabia,
Yeah, Dubai.
and the president's going to be a CEO of a large oil company. What kind of power does the president of the COP have? And do you think they can actually damage the progress that's been made and the process moving forward?
You know, I always really struggle with this because I've been taking students and, you know, other friends and faculty to the meetings for a while. And the first response is like, this is a horribly lost process, right? This is, there are things that are happening that are unfair, it's super slow, it's not effective. And I think that was my first response as well. But after having now spent 5 years, like learning who these negotiators are, seeing slow but steady progress, I actually am much more hopeful. And so one thing I would say is that I think that a lot of the countries with strong oil reserves have actually become climate heroes for the lesser developed and the least developed countries, because they are arguing for this like kind of need-based distribution of equity. What they want is they want money from the parties who are historically responsible to aid in the transition away, in just transitions away from that fossil fuel. And so some people might say that's unreasonable, but a lot of people actually say, you know, like, okay, we can call a lot of different people climate, or a lot of different parties climate obstructionists, right? But the reality is that in order to make a fair deal that everybody thinks is going to work, I've been surprised by listening to the Saudi Arabian delegates, listening to the UAE, and I do think that increasingly parties are coming around to this idea of we've got to get stronger climate finance to facilitate these transitions away. And that's what they're asking for. They're not necessarily asking to burn every single bit of carbon in their storage space. So it's a long way of me saying, Dan.
Yeah.
I don't think that the presidency has a whole lot of power there, and I think it's clear already that we're coming in with some undue influence as we have for the last couple of years. But I don't know that it will take us back.
Yeah, I guess more specifically, can the president influence what is and isn't included in the text? Can they make?
No, not so much. Well, they can influence it, but the Secretariat is ultimately the one. The UNFCCC is ultimately the one that's responsible for like draft texts.
Okay. So it's not the president.
Yeah, I mean, they can influence it for sure, but I mean, but all parties can, right? This whole system is based on a kind of weird consensus-based approach, right? Where one party can put brackets around one word and essentially shut down the negotiations for hours, right? Well, I mean.
Because brackets indicate that they don't agree.
Yeah,
Yeah.
so for example, the 1.5 degree report, should it be accepted? Should it be welcomed? And that was the topic of debate for like 6 hours. So, yeah. We welcome the report. We accept the report. Yeah, all right. I'll talk to you both later.
Oh, yeah. I need to move on. Yeah.
Sorry, I will share the screen. I'm not here on Zoom. I'm here in person. As well as.
But there are other people on Zoom watching.
Yeah, right. No, but that was just my face. So apparently I didn't log out.
Okay.
Apologies.
I
Yeah,
thought that was the beginning of your presentation.
no. Just to remind you what it looked like underneath this thing. Great. So I wanted to talk a bit about some of the work that I've been involved in terms of the broader conversation about the Anthropocene, which is a term that we've been using for decades. And there's a growing interest in officially formalizing it. And that process is ongoing right now. So for those of you who are not familiar with it, the concept you might have heard attributed to Paul Crutzen, who was a Nobel Prize winning atmospheric chemist who discovered the ozone depleting chemicals. But the term has actually been around much longer and is considered to have originated actually with a Ukrainian Russian scientist, Vladimir Vernadsky, who in 1938 used the term noosphere to basically account for the idea that scientific thought is now a geologic shaping force. So he's using it as a philosophical concept. Throughout the 60s, 70s, and 80s, Soviet scientists used the term Anthropocene to describe the Quaternary, which is our current geologic period. Then in 2000, Paul gets up at a meeting in Mexico and famously popularizes the term by saying, we live in the Anthropocene. So it sort of starts off as this philosophical concept, and now we're moving towards a formal scientific definition. So, is the Anthropocene a new geologic epoch? For those of you who are not familiar with this process and this record, we have formal stratigraphic boundaries here that are subdivided across many different types of units, and we are all the way up here, currently living, if you zoom in the Quaternary period, which has been divided into the Pleistocene, which comes from Pleistos, meaning most, and Kainos, meaning new. I probably butchered the Greek, apologies, meaning it's the most new geologic period, Quaternary being fourth, the tertiary, secondary, and primary, those have all been dropped. We don't use that framework anymore. Quaternary is kind of a legacy term. Then the Pleistocene ends at the beginning of the Holocene, 11,700 years ago, which comes from holos, meaning whole, and kainos, meaning new, meaning this is a wholly new thing, referring to the emergence of human cultures and modern humans and our spread across the globe. So if the Anthropocene is going to be a new geologic epoch, and these terms and boundaries get revised all the time, so then when did it start? That's the big question within this framework. So who decides? This process is actually really fascinating. There is an International Union of Geological Science. Within that, there's the International Commission on Stratigraphy. They basically decide when things happen in the geologic record. They formally define these boundaries. Within that, there's a subcommission on Quaternary stratigraphy that looks at those events in our current period. And within that, there has been for the last couple of decades, an Anthropocene working group tasked with defining this term or this boundary. These are the members, which include voting and non-voting members. And so these are the deciders. So these are mostly, almost universally geoscientists. And very famously, there was an article that came out in 2008. Must the Anthropocene be a manthropocene? Because there were almost no women on the Anthropocene working group. And also there have been critiques that this term or this concept and the definitions of it are being unilaterally decided by geoscientists, by geologists. They're not including social scientists. They're not including humanists. So there have been calls to have more more expansive inclusion in terms of these decisions. But as it stands, these are the people deciding the future of our current epoch.
And so how does this work? You have to have what's known as a global boundary strata type section and point, GSSP, a literal golden spike, in that it is drilled into the ground somewhere in the world where anyone can visit it, touch it, and see it. And it has to meet a certain set of criteria. It has to be defined, I think we're losing battery, by a primary marker. So a fossil disappears or shows up for the first time. It has to be datable with radiometric approaches. We need to know when it happened. There has to be regional and local and global correlation, right? So you should be able to find it in multiple places. The outcrop has to be of a certain thickness so that it's visible, cohesive. It can't be disruptive by tectonic or sedimentary processes. And it has to be accessible and free to access, which I think is a really cool feature. So when did the Anthropocene begin? Since this conversation started, there have been a number of proposed start dates dating back thousands of years to the emergence of humans. The early Anthropocene hypothesis, famously proposed by William Rudiman, suggests we might even go back to 8,000 or 6,000 years with the onset of deforestation and agriculture that first start to change the chemical composition of our atmosphere, increasing carbon and methane concentration, CO2 and methane concentrations. More and more recently, we've been kind of honing in on some of the more historic and recent events. And so now the current working group has basically come up with a list of these 12 candidate sites. And if you look at the period of time we're looking at now, suddenly we are very squarely in the historic record. So we've eliminated all the paleoecological records and periods that predate written history, and we're very much in the modern, in the 20th century. This has oh no, it's correct. There's a version of this with an incorrect swapping of 7 and 8. So I wanted to make sure I have the right one. From my spies inside the Anthropocene working group, I have learned that Crawford Lake in Ontario, which is a sediment core that has got barred sediments, is one of the top candidates. They've had multiple votes this spring, and they cannot get a majority vote. So there's currently debate within the Anthropocene working group with some holdouts who don't want to accept Crawford Lake, and roughly a 50 to 60% of the group is pushing for this particular one. So you're looking potentially at the next GSSP to define the Anthropocene, which is for soft sediments in a lake core. And this is very kind of unprecedented. So if this sort of process of trying to define the Anthropocene within the stratigraphic record has been very fraught, right? There have been lots and lots of candidates. Whenever I teach this in my class, all of my students basically reject every single one. So, and this happens like all the time. So a few of us have recently suggested that we, instead of an actual geologic epoch, sorry, that should be a new geologic event. Sorry, a typo there. That we instead propose that this is an event, right? Not event as in like, I'm going to the event of the season, right? But in geology, an event is a formal term that can be used to define processes or patterns that we see that may be discontinuous across space or time, right? Or they're diachronous. They span a large period of time all over the globe. So some events that are recognized as being extremely important in the geologic record include the emergence of the first land plants, right? This is a process that takes time. It shows up differently in the fossil record across the world, but I think we can all agree it was pretty important. Similarly, the great Ordovician biodiversification event is this. It's not necessarily formally labeled in the geostratigraphic record, and yet it's incredibly important. Also, the great oxygenation event, when stromatolites first start to pump oxygen into the atmosphere, creating these banded red iron formations that you see here, causing lots of impacts across the globe, including extinctions, right? But it's not formally defined within the stratigraphic record. So all of these are examples of events that are important. So the thinking here is that human impacts are continuous across space and time. The intensification has varied depending on where you look at in the globe. And so, we can really look at human impacts as a continuum and an ongoing process. And so trying to restrict that to one particular boundary is perhaps not useful scientifically. And so the event framework gets around those limitations. And the thinking there is that people have been shaping nature for at least 12,000 years across the globe. And so saying that we are only in the Anthropocene in the last couple of years or last couple of decades really erases this global process of human environment relationships through time. And really, the fact that we have struggled so much to come up with a formal definition of the Anthropocene may itself be data. That's evidence, right? That this formal stratigraphic framework may just not fit, right? It may not be appropriate. So that's the thinking for the event framework. The Anthropocene has also been suggested recently, formally argued that this should just stay in the formal concept. Why do we need to have a formal definition? This is how it's already used. It's widely used as a term in the arts, in the humanities, in social sciences. It is a much more inclusive definition if we use it as a philosophical concept. So Graham Swindells and some other geographers have recently proposed we should just keep it that way. By trying to restrict the definition of the Anthropocene, we may actually be doing harm in terms of excluding other sciences. And so some of the thinking here is that, again, we want to stop thinking about human impacts as a binary, right? People know people, good, bad. This kind of thinking, people bad, no people good, has been used for a lot of colonial harms, the erasure of indigenous peoples, et cetera. So having a formal boundary of the Anthropocene has tons of different implications. Also, their argument is that geologists don't own the Anthropocene, right? The understanding of humans' place in nature is bigger than any one discipline. Here is geology, and you can see, if you can see these little tiny fine lines, geology is not very interconnected with other disciplines. We don't play well with others, right? So maybe we shouldn't be the ones to decide something of this broad scope that's already being used by many other groups. And again, coming back to this idea, any definition of the Anthropocene has implications, right? Does that mean that colonial impacts were not damaging because they weren't in the Holocene instead of the Anthropocene? What are the long-term impacts of this formal definition? So with that, I have now proposed 3 potential definitions for the Anthropocene, either as the Anthropocene Working Group would have it, a formal geologic epoch with a clear boundary, a geologic event that's diaphanous across space and time, or an informal concept. And I don't think, so if, Karina, can you click on that link? It should bring up a website. Oh, is it not working? That's fine. I was gonna have us all vote with our cell phones and then we could see what the results were. So we'll just do it with a show of hands and just try not to let your peers pressure you into making the wrong decision. So, all right. How many of you think, so let's pretend we're the deciders now here at CCI, this interdisciplinary group spanning all of these disciplines. How many of you support the work of the Anthropocene Working Group in finding a single stratigraphic unit and defining a new epoch formally? Raise your hand.
What are the options?
Epoch, event, informal concept,
Okay.
right? So a formal geologic epoch, okay? How many of you are swayed by the argument that we should be thinking about it as a geologic event? So still defined within geology formally. Okay, with your hands.
Yeah.
How many of you think that the Anthropocene should remain an informal philosophical concept as it is currently used? All right, well, I don't know if there's more support for the second and third options. I didn't count hands, so but I think that's very interesting feedback. I'm not a member of the Anthropocene Working Group, so I can't comment on it. And I suspect that they're going to make their decision one way or the other. But this is a really good time if you have an opinion on this, which we all should, as Anthropocene adjacent researchers. You know, this is a time for letters, op-eds, commentaries, etc., because the decisions are being made about the Anthropocene and the future epoch that we live in, literally happening right now. So thank you. I appreciate your time.
Do you want to do like 30 seconds?
30-second questions. Greg.
Could you comment briefly on sort of the restriction of these proposed sites all being Northern Hemisphere in Australia, and maybe the constituency of the group themselves, like where they're from?
I think that there is a pretty good mapping of constituent sites against working group members, but that also like reflects the scientific body as a whole in terms of, you know, where research is conducted and published. and considered globally. Some of the criteria for GSSPs, easy to access, you should be able to fly there in a day and get to one, right? That has limitations, and easy to access for whom, right? Is Crawford Lake easy to access for me? Heck yeah. Is it easy to access for my colleagues in South Africa? No, right? And so there's some, you know, blinders built into those definitions, but I think it reflects, you know, like Africa has a lot of has very few GSSPs, right? The distribution of the proposed Anthropocene sites, if you put the map of the current GSSPs for any geological strata, they kind of overlap, right? And so I think what we're looking at is the biases within the scientific record there, or within the scientific community. Yeah, thanks. Sorry, come and sign later. Sorry.
All right. So I'm gonna do a takeoff with Jacqueline here. The geoscientists don't work all together, so I'm gonna talk about how we're trying to improve that. To basically build a more inclusive, collaborative, polar geoscience community that we have at our fingertips in Alaska. In 2019, we were able to bring the Geoisosphere Research Program to the University of Maine, and that program's been around since 1946. And I'm going to talk a little bit about, we only have a couple minutes, a little bit about what we've done for the past 5 years to develop this ice field program. Can we move this forward? So for those of you that are unfamiliar with the ice field program, we have 11 field stations across the Juneau ice field. It's about a 4,000 square kilometer area. The largest field stations can hold upwards of 70 people at a time. And we have been running a program there for a number of years. This is a picture of one of the field stations looking over the Gilpin Trench. And the program itself is designed around education. So we're basically teaching students that come to the program, undergraduate students mostly, about polar Earth system science. So everything from the atmosphere to glaciers to terrestrial systems to the ocean. On top of that, the students that are on the ice field, they spend a large amount of time working with scientists that are there to do legitimate research. So we're basically coupling hand-in-hand research with education. This year, we have funding coming in from the National Science Foundation, NASA, Patel, and the Department of Defense totaling upwards of $5 million in collaborative funding to support the initiatives and support this coupled education research and this new polar proving ground concept. And the way I've phrased it to people, it's kind of like a mini US Antarctica program. The Antarctica has roughly 1 million people, 1,000 people that go down every year. This year, we're having upwards of 220 participants that are coming to Alaska. Of those 220 participants, we have about 100 low-income and first-generation high school students that are coming to Alaska. We have roughly 40 undergraduate students and a couple dozen graduate students who are involved in the program. The rest of them are scientists from across the country and actually internationally as well that are doing legitimate research in the field, and the students are participating in those research activities. I did want to point out the remarkable group of people over here on the right. You've seen talks from Emma, from God, I can't remember. There's a whole group of us. It's a big group. I feel honored to work with this group every day. They're an incredible group of people. A lot of what I'm going to show 4 examples of research that we've been doing, and it's in large part led by the individuals you've seen talk. And you also can check out some posters out front about some of the research if you're interested in that. Before I show those posters, I want to mention we have about $17 million of proposals pending. They're with the federal government. $5 million was appropriated by Congress this year, bipartisan support with Alaska and Maine, and it was appropriated. So the money is in hand of the government that we have a pre-proposal pending for. And they told us to expect another $5 million next year. And on top of that, we're working with the School of Engineering to try to build new field stations on the ice field. And they have also initiated a new basically a new field program for their students to participate in our activities. So I'm going to flip through the examples that we have funded very quickly. You can talk with any of the students you've seen here. We have this new high school program that's funded. We're bringing 100 upward bound students per year to Alaska. They're all low income and first gen students. This is a group that was from Florida. I think we have 120 students coming this year from various groups. With that, they're learning and actually doing hands-on experiences related to polar system science. We have a new career grant, and many thanks to, again, some of the pre-research that our students have done here. Kaylee Manello will be working on this for her graduate work, and several others starting this summer, looking at burn meltwater. And you heard Kaylee and others talk about the importance of water storage in glacier systems. We have a big team that's focused on that topic. We were funded by the Department of Defense to better understand spatial variations in meltwater content storage and snowpack. So this is a model built by a prior student, John Maurer, a deep learning model, modeling snowpack thickness across the new ice field. Again, Kaylee did a great talk yesterday talking about that. And on the right-hand side, we're installing a upward-looking radar system that is also mentioned on a poster. I think Keegan has a poster out front. And then the last example, we're also doing planetary work. We have a big project funded with NASA, JPL, University of Washington, and Tennessee, where they're building and testing an autonomous system that will ultimately end up on Europa to drill through the ice shelf and look for signs of life. So we're hoping that will happen in about 10 years. The plan is to test this system up on the ice field this coming year. And Renee has a nice poster out front that she can kind of fill you in on that project as well. So I think that's it for now. If you're interested in participating in the junior ice field in any way as a student or as a faculty, we welcome you. You do not have to be straight up earth sciences. You can be interested in science policy, science communication. We have it's kind of a melting pot for a wide range of individuals. So we're looking for more involvement from the university from now and in the future. I think with that, I'll take any questions.
One quick question, person.
Yeah.
What's the ice thickness to surface the bedrock? What's the range?
Yeah, so Taku Glacier is the thickest temperate glacier on Earth. It reaches roughly 1,500 meters deep, almost 1,600 meters right in front of one of our field stations. They've measured it with seismology. So far, our ice radars haven't been able to penetrate that deep. The site that we're drilling for the NASA project is 300 meters deep. About 100 meters is equivalent to a kilometer depth on Europa from a physics perspective. So we're trying to aim for 3 kilometers depth on Europa, but that would be 300 meters on all right.
Thank you.
Good morning, everybody. For those I don't know or don't get a chance to see quite enough, my name is Kylie Daly. I'm a research faculty here at CPI. I research mostly issues around environment and human health, with in particular a lot of work on flooding sources. So the project I'm going to tell you a little bit about today is a project that's kind of getting started, getting up and running. We've been building up some partners who are going to work together on this work. So it's kind of a nice time. I was glad to have this opportunity to sort of bring it to this group, maybe hear about it, and hopefully hear more about it in the next few years. So my collaborators on this project are Angela Daly and Kathleen Bell, who are both from economics, as well as Shailene Jane from engineering and with us here at CCI. A little bit of background and impetus and kind of the objectives and why the reason these headlines and photos are up here. So household water insecurity in the Arctic specifically. And we've sort of heard a lot about water and maybe water security and freshwater sources and lots of presentations. So what I'm going to be talking about for the next minute or two is thinking at the household scale, or maybe at the community scale or even individual family scale. So we're way down at that level. And sometimes when we hear about water insecurity, at that level, we tend to think of maybe not here in North America, not what we call high income countries, United States, Canada. We sometimes think of maybe some lower income parts of the world. But this exists in many pockets around North America, and in particular in some Arctic communities, some indigenous communities in, I'm going to talk a little bit about Canada specifically. So this is kind of an issue myself and others, and I would say a few people have been concerned about and been working on in different ways over a number of years. And the people who live there, including public health organizations, they've certainly been concerned. All of a sudden, 2020 happens, and we start to kind of go back at least a little bit to the building blocks of public health. We need hygienic practices. We need water. We need water in ample quantities. So a lot of these communities have what are called decentralized systems. Water is trucked to your house. All of a sudden, they're not getting enough, there's more attention. Okay, increase that. So we're starting to get some attention on this issue. And then in late 2021, pretty much halfway through 2022, Iqaluit, Nunavut, which is a city of about 8 or 10,000, is the capital of Nunavut up on Baffin Island. They have a huge water emergency. It's a really multifaceted issue. You could take a quick look into it. It involves all types of climate and environmental issues of how it happened. Used to be a military base sometime in the 60s or 70s when that was being cleaned up. A huge fuel cell was just bulldozed over, ended up being underneath a current day water reservoir. Nobody knew about it. It wasn't in any plans. Things start to shift and thaw. That leaks. A huge emergency. Again, just pointing that out to highlight the issue. So here's a good opportunity. We have some momentum. This is now on people's minds. So we're looking to pick up some work on that and bring it to a bigger scale. So we've, like I said, gotten started. We're kind of in that partnership building phase. So thanks to a UMaine Arctic Seed Grant, we got some work done on a really nice paper that's coming together, in particular with 3 student authors, two who have graduated, as well as a very soon to be graduated student. We have that going. We were also invited to join what's called the HWISE Research Coordination Network at NSF. So HWISE is a network that's been doing this type of water security work, but in other parts of the world. It's these communities that I mentioned in North America aren't really on their radar. So it's been a great group to be a part of and learn some of the standardized methods and techniques and ways to sort of work on this issue that are used in other places. From there, with that paper coming together, we had an opportunity to, we're invited to participate in a presentation and panel at an ArcticNet conference in Toronto back in December. And despite the sort of dour looks on the faces, it really was a very interesting and useful panel where I had a chance to talk about these types of issues with representatives from Arctic Canada, as well as some communities in West Greenland. So then from there, we start to put together a good group who really wants to work on this and continue with this issue, which comes down to that block. We were invited to join a thematic network that's part of the University of the Arctic. And then these are 2 partners. These are actual community members, community organizations, those other 2 logos. We have some government of Nunavut partners. And I just wanted to quickly mention this logo here with the sort of ulu knife in the brown bullets says Siravik. So in kind of thinking about this issue, this was a food security group. We hear a lot more about food security in some of these communities. This group had done everything right. They have a huge program going to address food security issues. They have breakfast programs for kids. It operates as a food bank. They have space, they have resources, they have funding, they have people to do the work. In a span of 30 days, 20 of them, their community had no water. You can't do anything. You can't, how long can you do those things? So just to kind of give you an example of how this sort of impacts on a number of scales, life in these communities. So we're there working with this group, like I said, hoping to keep taking this to the next level. Thanks.
Yeah, we don't have time for
No
questions.
problem. Okay, well, I'll be around. Thanks.
Thank you.
Good morning, everyone. I'm happy to provide a short update on some things we started last summer in Croatia with my colleagues at the University of Zadar. I've been working with archaeologists mostly over the last few years outside of the city of Zadar at a fully archaeological site, trying to understand issues of urbanization and landscape change. Most recently, since the pandemic that kind of shut down our operation, I've turned my gaze more towards the living city of Zadar and working with some geographers as well to try to understand really issues of urban land cover change, loss of green space, and really understanding the pace of change that's become unprecedented in terms of urban land growth. And I think as an archaeologist, the way we're viewing this is provided that deep time perspective is the only way to really identify and showcase how unprecedented the pace of change is in terms of urban land cover. Across the Mediterranean region, well, I guess more globally, we can look at the UN's report on world urbanization and recognize that in 2007 was a key year where more than half of the world's global human population resides in cities. At 1950, that figure stood at about 30%. By 2050, it's projected to be about 2/3. That's pretty remarkable. So My interest is, what does that look like on the ground? In terms of urban land cover change and expansion. So we've been looking at Zadar. It's pretty typical across Mediterranean landscapes of rapid urbanization, displacing former agricultural landscapes and homogenizing these kinds of environments. So at Zadar, we have a 3,000-year record, as with some of the other archaeological sites we've been working at. Liburnian Iron Age, it was founded as an Iron Age hill fort back in the early first millennium BCE. It was transformed into a Roman colony around the turn of the millennium. Survived through the Middle Ages as a walled city, transformed by the Venetians into a stronghold on the Adriatic. It's taken over by Austro-Hungarian Empire and is a contemporary commercial city in the Eastern Adriatic today. Historical maps like this from 1798, and the Austrian Cadastral Survey is really important to us in characterizing what the diversity of landscape looked like outside. Everything archaeologically tells us that the urban center of Zadar was focused on the peninsula, and most of that mainland was green space. Visiting the remaining relics of these green spaces this past summer, there's a lot of dry stone field walls and terraces that are still there, but the urban fabric of Zadar is really consuming all of this, and a lot of it is being driven by the tourist market and erection of new apartment complexes. It's taken over this, so they're losing a lot of this green space. Most characteristic of this, I'm not sure why it's not coming up. Could you push the forward arrow once?
Yeah.
We can look at 1944 Royal Air Force images and superimpose them and just see how rapid. This is 1944, right? So the last 50 years is remarkable. What we do see is this overarching grid of lines is from Roman centuriation. It's agrarian land survey from the Roman period, 2,000 years ago. All of these other lines are more historic field walls, stone cairns, and terraces that are meant to clear field surfaces and improve the land for agrarian production. That's what's lost, right? Through all of this, it's being displaced elsewhere into less productive lands. But the last remaining vestiges of this are still available in these little green spaces of the city of Zadar. So we're trying to think about these problems through that lens of long-term urbanization, the pace of change, and what that might mean for socio-ecological resilience moving forward for a city like this. Thank you. Yes.
Have you had a chance to talk with city government about this? Do they have any interest in what you're uncovering?
I have not, but I did just find a report from a municipality that's targets in terms of urban development, the protection of green space. Some of what they've targeted is already developed. But what's interesting here is you can see where there's old green belts, the drainage systems, some of those are still left. So I think that's important, but some of these others that were targeted in that report are already developed with apartment complex.
What year was the report?
2018 even. I feel like I got to them late because some of them in 2018 satellite imagery, fully green space. I go there last summer and they are full-blown apartment complexes. It's happening very quickly.
Okay.
Yeah.
Is that ocean at the bottom there?
Yes, this is the Adriatic down here. So there's a historic peninsula. Everything was developed here, urban.
And I'm just wondering, what's the topography like? Is that at risk of from sea level rise?
Naturally, because of the coast, yeah. It's a gentle rise. Most of this is low-lying terrain, but it's a gentle incline going inland. So sea level is an issue, but also I think going forward, the next century are predicting to be hotter and drier summers, but with some pronounced precipitation events. So that increased concrete surfaces are going to be a problem, losing some of its resilience with respect to moisture, vegetation, all of this where you have a good slope coming down. Thank you.
Perfect. All right. So today I'm going to provide, just like Greg, some updates on the projects that I've been working on, which have been characterizing iceberg geometries and especially their melt rates. And so icebergs are this really dynamic feature that had from glaciers travel to the open ocean and then act as point sources for fresh water. So with that, they can modify ocean circulation, fjord circulation, they get in the way of shipping lanes, they modify a whole bunch of a slew of ecosystems. And so what this project is really focused on is figuring out what that geometry is, because that's going to drive where that freshwater injection is happening in the water column, as well as how quickly they're moving, what currents they're being caught in, things like this. And so if we just take a look, pretend that this is a beautiful image here. And so back in 2017 to 2019, we went out, we did 3 campaigns in Southeast Greenland. We used drones. So kind of if you imagine these little blue squares, those are all drone images. We used those to create a 3D surface model of the iceberg on the top. We are out here in our ship, which you can't really see. We used sonar to image the subsurface of the iceberg. And from that, we were really able to advance previous knowledge of iceberg shapes. So prior to this, they were really idealized as cones and cylinders. After this study, after we went out and we surveyed all of these, we showed that's not a very good approximation. It's not going to get us very far in terms of using icebergs and inputting them into different models. But one of the shortcomings of this is that when we were using sonar, it really was line of sight. And so we weren't getting the bottom of those icebergs. That's where the models had predicted was going to be really high melt rates. And so we were going to get a lot of fresh water that was injected at that level. And so what we did was we decided that we were going to put out an AP res on top of this iceberg to measure subsurface melt. And so both Inga and Emma gave great introductions to what AP res is. And so in order to establish a new method, we had to meet some benchmarks. So we had to recover our AP res instrument. So we had to choose an iceberg that didn't look like it was going to capsize or deteriorate. We also had to locate that iceberg. So icebergs move. We needed to be able to land on that iceberg again with our helicopter to pick up our AP res. We needed to be able to process and interpret this data. So this dove into a lot of different technicalities of how AP res is collected. We have an iceberg. It's not on an ice sheet or an ice shelf. And so that means that we have sidewall returns, which are not considerations when we're thinking about these radar systems being deployed terrestrially. We also had surface melting. We could have also had movement of the system on the surface of the iceberg. And we also wanted to make sure that what we thought we were seeing in our AP res data is what we were actually seeing. So we needed to have independent validation of all of the findings. And so we accomplished this in 3 ways. First, we wanted to find an iceberg that was in an optimal location in the fjord, so far enough up fjord that during our deployment period, it would not escape. We also wanted to find a good iceberg geometry, so large enough to land a helicopter on, fairly straight walls, so we weren't dealing with returns. Again, this was a best guess because we had not done any of our subsurface surveys yet. And then we had to be really careful in how we deployed this AP res setup. So this included a lot of ice screws and trying to decrease the amount of melt that we were going to measure, while also deploying this setup in less than 15 minutes, because that's how long our helicopter was going to wait on the iceberg for us. So the long story short is we were successful in most ways with all of this. So we deployed our AP res, more or less didn't sink in all that much. We were able to get sidewall returns and also basal melt rates. And we were also able to confirm that we were getting sidewall melt rates that coincided with when we would expect to be receiving a signal from our AP res. So overall, it was mostly successful. And that's where we're at. So thank you.
Questions? This might be a really silly question, but does anyone ever try to do this with underwater drones?
Yes. So this has been done by the oil companies. They're extraordinarily expensive. They also need to be tethered because they need such an incredible power supply. And so, yes, the short answer is yes. The longer answer is that tool is outside any NSF budget. Yeah, I would love to be able to use one of those underwater submersibles.
Do they share their data with you or do they hoard it?
Only recently, and their version of digital data sharing is a JPEG. So it's not, so I can get pictures of what it looks like, but I can't actually get a lot of this data. Yeah. We're working on it. All right, thank you.
So there was a last presentation by Sudarshan, but he couldn't join today. So I think we will move on to the closing remarks by Dan Sandwise and Dr. Paul Majewski.
Oh, yeah, yes. Okay, well, sorry about the last two presentations. Before we forget, let's make sure we understand who put this together. Becky, Betty, Dan, Andre, all of the moderators. So let's give them a big round of applause. And of course, thank you to all of the presenters. And as always, the talks get better and better. So the next question, the next point is that this is the first time we've used this room for such a large assembly. So we're going to try and purchase an owl, an expensive owl that will allow people to, it'll ideally, if we hang it from someplace, if we can, it'll allow people who are speaking to be immediately recognized. It'll also do a better job of picking up their voice. So if any of you have any experience with owls, please tell us. We know some people who've done this already. And we can invest in it. It's not a big deal. So the next thing I'd like to talk about is what I like to call serve. Many of us will be going into the field very soon, working in the laboratory. This is the last time we're going to see each other, probably in a group like this for quite a while. So ideally, but not ideally, I'm still the icebreaker. So write these four letters down, SERV. And I'll tell you what it means. Safety, enjoyment, responsibility, and value. First, let me tell you why I'm telling you about this. So I've been in this institute for about 22 years. I have a pretty diverse background, and I've spent a lot of time thinking about a lot of things. Like all the other faculty here, I've gone through all the faculty ranks. I've had plenty of graduate students I've worked with. I've taught undergraduate classes and graduate classes. In terms of administration, which is a little less common around here, I've had a lot of administrative roles. Last university I started in quite a while ago, I was the only person who was in my field. Out of that, as many of you are doing, I grew a small research lab, and then eventually it became a group, and then eventually became a center. And then I co-founded a very successful institute at the University of New Hampshire. I was also the vice president of research at my last institution. And now, of course, I've been the director here for about 20 years. So I've gotten to see an awful lot of the inside, sort of on the ground things that we all do, but I've also seen the way we're viewed from the outside by the administration. I've worked with many state agencies, non-governmental agencies, but the thing I love the most and the thing I care about the most is research, actually. And I've spent a lot of time doing research. I've led more than 60 expeditions, not participated, led more than 60 expeditions to the remotest parts of the world. I've been in places where you go for 100 to 120 days, completely unsupported, no radio, no map. I understand what it's like to be in a situation in which you're completely cut off. I've led large programs with 50 people, with tons of aircraft going in and out, and a variety of other things, international programs, 21 countries. And I say all this because when you begin to think about the important things that we all need to consider. The longer your perspective is, in this case, the better your idea of how you're going to deal with it. So this comes back to what I call serve. Serve, number one is safety, and I'll just give you a couple of examples. In all of the things that we do, we're becoming more and more aware of this. We have ways in which people are trained before they work in the lab. We have ways in which we understand how we're supposed to deal with emergencies. But we also, because we do so many field programs in this institute, we have a safety planning form now. We initiated it about a month ago. It is absolutely required that every single person who goes into the field fill out this form. I shouldn't say every person, every leader of a project. So who's the leader of a project? In some cases, it's one of the faculty members who's a PI. In many cases, because of the Churchill Fund and the Sturgis Fund, it's graduate students. So we want to make sure that you are all well qualified, that you understand what's going on, that we have a way to communicate with you. We have had accidents in the field, in some cases very bad ones. It's not necessarily because anybody did anything wrong, but we want to be able to communicate with you. And Betty and Becky are the people that you probably will come back to. So they need to know where you are. We also want to make sure you all have experience, all of you who work in the field, but you have different levels of experience. We want to make sure that you really understand and can think through all of the logistics issues that you might become involved in. So those reports go to Betty, but they go to me. And I look through every single one of them. And I try to think about what is it that you're doing? What could in fact be a problem? And when you have spent as much time as I have in everything from safe to very dangerous situations, you always have to think about what might happen. What is the worst thing that's going to happen? And I want to make sure that you think about those things too, hence these forms. The second is enjoyment. If you're not enjoying what you do, if you don't like being in the field or in the lab, you're doing the wrong thing. We're all here because we're passionate about what we do, and that's wonderful. Quite truthfully, from my own point of view, I always like to say that it was at least 10 years after my PhD before I actually cared about science. I got a PhD because I wanted to go all over the world to remote places. Yeah. But eventually I realized that we could actually do, me in this particular case, but you too, do something valuable. It's a different world now. I think you're all being called upon much more so than ever before, not just to go to a place to have fun, which is wonderful, and you should, but also to be able to do something that perhaps will give back, hence the term serve. Third thing is responsibility. Now, we all have responsibility to each other. So when we work in buildings, in labs, we want to make sure that we walk around and clean places up. We want to make sure that we're careful with the things that we have. If we break equipment or damage field equipment, nobody's going to charge you for it, but please tell people there could be serious safety issues involved with sending somebody into the field with a tent that has a rip in it. Andre and I and others, I've been in 100-mile-per-hour windstorms that lasted for 17 days. People can die if you're not careful with the sort of equipment that you're releasing back out again. We're all one big group when you think about the safety of this equipment. You also have responsibilities to the way you deal with other people, not only in classrooms and other places, but we're learning to become much more respectful about the way we think about people. Do more than that. Be empathetic. Empathize with the way they are. We all have strengths and we all have weaknesses. We have to make sure that we understand and we can see these. And when you build a really good field team, it's built upon not just one person being the strongest and the most intelligent. It's based on the strengths and the weaknesses of everybody. Also related to responsibility and actually to the safety plan is to make sure you're all very familiar, particularly the graduate students, because of Sturgis and the Churchill Fund with budgets. We have a very strange situation in this university. It's actually in most universities. On June 30th, everything restarts financially. If you have not submitted all of your statements that need to be paid, all of the bills by June 30th, Betty and Becky spend the next few weeks frantically trying to balance the books. it's a really unnerving time period for CCI admin. When you have a concur report, get it back fast. If you don't, we hear about it constantly, and we're very proud because of Betty and Becky that we have such a great reputation with the rest of the university. But our concur reports sometimes are not appearing as fast as they should. It creates an immense amount of stress. And that's part of being responsible, is not creating stress for people who are dealing with so many of the things behind the scenes that you'll never see, that you don't necessarily know about. But it can create a tremendous problem if you don't get paperwork back in again. More and more accountability is being required, which is a good thing. But at the same time, it requires that we all work together. And then the final thing in SERV is value. So obviously, you're doing what you're doing because you want to get a degree or because you want to advance your career, and that's part of the value to you. But when you think about what you're actually going to do with the research that you have developed, you need to think about what the value is. You know, think carefully. Are you rediscovering the wheel? Make sure that you read past literature so that you realize what it is you're talking about and what the context is. If you look at, for example, Science and Nature, and I've been looking at it for a long time, but I've published a lot in it. Every 20 years, the same thing very often will reappear. Make sure that you look at literature that may not even be available as a PDF. In many cases, we're doing things that are very discipline specific, which is great, but there should still be some sort of a value to that, some value to the scientific discipline, ideally some value to a much broader public. We live in a time of great change. Things are everything from climate to politics, etc. So you want to make sure that you think in a very interdisciplinary way about what you're doing and whether or not it has value to other people. Everything that we do costs money. In some cases, it costs a lot of money. And therefore, it's important for us in the process of bringing value to these things to be able to come up with papers, reports, presentations, make sure that they're timely. You're actually working in many cases under contracts, and you want to make sure that you that you fulfill those contracts. And at the same time that you think about where did this money come from? And this is for Churchill and Sturgis, but it's for the National Science Foundation, it's for NOAA, it's for NASA, it's for the university. Make sure that you are trying to bring some value, and that value is not just to your own discipline, but it's in general. And then finally, under value, we're becoming, as an institution, the University of Maine, much more interested in interdisciplinary problem solving. And that's, if any organization in this university or system can be pointed to as one that is multi and interdisciplinary, it's ours. But it's very easy for us to begin to depart into our own little disciplines. And I'll try to think about how what you've learned here from people talking about other disciplines, how does that actually apply to what you do? Policy, understanding the distribution of icebergs, training students, understanding water quality, all of these things that you've heard about. So ideally, you'll begin to think much more, not just about your own project, but also how all of these things come together. So that was my lecture. And again, think about it. If you write those 4 things down and think to yourself, what is it that I'm doing? Is it safe? Am I having a good time at what I'm doing? Am I being responsible? And am I providing value to myself and everybody else around, and ideally the world too?
Okay. Been a great day that we've had. I guess it's been about 24 hours. I've done how many of you were part of the online Borns in 20 and 21? Okay, so you know the way I comment on papers, and I have a comment on all 25 of the student papers. Now, I know I'm also standing between you and lunch, so here's what I'm gonna do. I've asked, we're also having the awards. I'm gonna move the awards forward as soon as they come here, and then once because we really want to celebrate the great talks and give out the awards. And then I will start going through my comments and you can leave when you can't take it. Don't leave it too long. Okay, so let me just go find Betty and see if I can get the awards. I know they're ready. And we'll do that first. We are set. All right. We're going to start with the poster award. Remember, this is for first year students who are required to do posters. And we have a tie for first place between Ali Berry and Micah Pugh. Please come forward and receive your award. There you go. Give her a big hand. Next, we'll go to the paper awards. We have 3, 3rd, 2nd, and 1st place. And in 3rd place, Bailey McLaughlin. In 2nd place, Inga Kingsted. Congratulations. And in 1st place, Alessandro Berghetti. Next, we come to the 2 awards for the exploration funds, and for the Churchill Award, Andrea Terrell. And for the Sturgis Award, Elizabeth Leclerc. And finally, we also have an award for outstanding service by a graduate student. We had the largest number of nominations ever this year. They were all extremely worthy, but we could only choose one. I want to ask that the nominators renominate. If your student didn't win this time, please renominate for the next time, because they are all worthy of winning. And the winner for this year is Madeline Woods. We will make sure that they get their awards. Now, I'm going to start going through my comments on the talks, but like I said, you're free to leave when you just can't take it anymore. All right. Emily Blackwood kicked us off with a model presentation on the ethics of virtual archaeology, a topic we can all dig. In her virtual environment, not only can she clam up, she can clam 3D. As an archaeomolluscan analyst, from my shellfish perspective, this is wonderful. More importantly, she calls attention to ethical considerations that we must take into account when we're doing our virtual work. Xander Roman gave a timely talk on glacial chronology in the Wind River Range. In passing, he addressed the eternal question, to be E or not to be E. His data support the utility of beryllium 10 dating for resolving glacial chronology, which is a real advance. Lygia Navarra assessed water quality in South Greenland, which is hardly a dry topic. It would be unhealthy not to pay close attention to this research. Alessandro Marighetti talked about the nature and disappearance of the mammoth steppe biome, which are really big issues. Although he could only graze over the related topics, he gave us the straight poop about what he's doing to learn more through multi-proxy analysis of coprolites. I do worry about how he considers coprolites to be donuts, and I'm not sure that I want to visit his field camp. Lizzie Gadrani gave a high caliber presentation that shone a light on calibrating laser ablation of ice core samples. In her talk on the effect of public policy and the pandemic on lead pollution from Asia, as seen in Alaskan cores, Hannah Brooks tackled a really heavy elemental problem. Work is in progress, but she may well find that the effect of the pandemic was more systemic than its policy, and you might be able to make a song out of that. Lauren Woods evaluated Mercer's paradox about interhemispheric synchronicity. Her results appear to sync closely with Xander Roman's work on the same project, which is entirely appropriate and should no longer to be considered an eccentric finding. This work raises the question of whether Milankovich's theory should be phased out. The work on the Wind River record really blew me away. Bailey McLaughlin planted the idea that trees' climate tolerances may not differ across life history, all the geographic ranges do move. This may be a niche topic, but it's one that's important in growing our understanding of past forest ecology, as well as plotting the future. Also, the same methodology could be used to branch out to other categories of data or taxa. Madeline Woods gave a dynamic presentation on a current hot topic, Holocene temperature history of the Gulf of Maine. Part of the work is outreach, and Madeline let us see her research video. Despite all the bugs in the video, it worked quite well. Andrea Terrell's talk on New England alpine communities was hardly a pie-in-the-sky perspective. She truly elevated our understanding of the structure of these important communities and showed that no plant community is entirely an island. Kaylee Manella put her snow job on our radar. And by snow job, of course, I mean her study of snow properties in the Yukon Territory. She also showed that archaeologists aren't the only ones whose work is in the pits. Suman Acharya got us all high into Nepal, that's where he works. He discussed how different people and places are affected by climate change and cast climate impacts in a sociopolitical context. Elizabeth Leclerc presented her current work on resilience to El Nino on the north coast of Peru. She's near the start of this research, but one can hardly characterize her El Nino work thus far as baby steps. Nor is it precipitous for her to outline her research and process on El Nino. Her discovery of indigenous villages still occupied during the 1578 event will allow her to adapt her research to include direct comparison. Scott Braddock offered a penetrating commentary on his glacial GPR work in Alaska, which is related to the snow job that Kaylee discussed. He addresses a topic that is of critical importance to the University of Maine, although in a very different context, namely retention. Inga Kinstedt shared her accumulated wisdom on snow accumulation and melt percolation in Asian glaciers. This reminded me a bit of that, I'll get this right, Galifianakis' show Between Two Ferns. Inga also explained about her plans to wise up even more in the next field season by doing cluster coring, and I'm not going any further with that. Emma Irwin did her level best to understand the stratigraphy of the Denali ice core and whether or not it gets really old, using various radar systems. Among other findings, repeat measurements with the APRES system or radar had a strong correlation, which seemed appropriate. Marina Miles discussed her emerging research on Mount Katahdin during deglaciation. Megan Spoth waxed eloquent on her use of multi-proxy methods, including plant wax in the American West, to study hot topics such as fire activity, how hydrological changes might put a damper on fires, and the growing understanding of the role of fire in plant community composition. Through the long-term perspective she's developing, she may well be able to help predict whether climate change will further dry out the region or rain on Westerners' parade. Moving to today's talks, Madeline Landrum kicked off our day 2 by discussing a burning issue, Maine's fire history. Through a multi-proxy approach, she demonstrated that in Maine, the presence of different human groups, and especially European colonization, are associated with regime change, which is to say fire regime change. Causality is still obscure, sort of smoky, but Maddie is getting closer, or one might say warmer. Pradma Pahadi's study of leaf economic spectrum, or LES, for tracking environmental change showed that less is more if some unanswered questions can be resolved. She presented a fruitful analysis of wild blueberries as a test of LES's ability. Catherine Follansby explained how agritourism can become a growth industry for Greenland. The key question is how to successfully farm out the tourists to distribute the income to those who need it most, the farmers. This requires working directly with the target people and places, otherwise recommendations will be inappropriate and thus miss the mark. Sydney Barada's productive consideration of the relation of sediment plumes to melting tidewater glaciers in Greenland is a feather in her cap, plumes. Although plumes per se make it hard to shed light on this topic. Avery Lamb explained her work on the historical reconstruction of harmful algal blooms or HABs to better understand the effects of climate change on these bad habits. Her talk included a genial discussion of the problems with using said DNA. Douglas Hassan is working on understanding the relationship between climate change and the electorate, a topic to which he is clearly devoted. Indeed, he noted that voters do not rank climate change highly in their priorities. Possibly they view outcomes of climate change, such as devastating drought, as simply too dry to be engaging. Doug's trying to figure out how to make climate change a hotter topic for more voters. And finally, Eric Brown gave us a shrewd analysis of how to model tree shrew climate niches. Understanding the relation between these wild tropical mammals and climate is an exciting, if difficult, avenue of research. Tree shrews are hardly a tame topic. Unfortunately, Zoom was behaving shrewishly and we couldn't hear all of the talk. That's it. Thank you all.